There is a moment in the history of everything that no instrument can reach, no equation can hold, and no memory, cosmic or human, can preserve. A moment so quiet that silence itself would seem loud beside it. A moment so empty that even emptiness had not yet learned its name. And it is here, in this unrecorded breath before creation, that a truth waits in the dark. Motion did not exist, not movement, not vibration, not rotation, not the trembling of a particle searching for a state. There was only stillness, absolute, seamless, perfect stillness. This is the part of the universe we were never meant to see, not because it was hidden, but because nothing inside it had yet begun to shine. You're listening to Whispers of the Universe. If you're gentle enough tonight, if your presence feels soft and sincere, a small touch of support, one like, one share, one quiet subscription helps this space stay alive. Thank you for offering light in a place devoted to quiet. Now breathe slowly and follow me into a reality where nothing moved. Before the first atom, before the first photon, before the first drop of energy learned how to ripple, there was a vastness without direction or form. No length, no width, no height, not because it was small, but because the concept of where had not yet appeared. In our universe today, everything begins with change. A star burns because its core shifts. A planet forms because dust spirals. Time flows because events unfold in sequence. But in the beginning, there were no events. And without events, time was not a river, it was a locked door. Imagine trying to measure time in a world where nothing changes. What would you track? What moment would be before? What moment would be after? You cannot mark a clock if the hands never move. You cannot define a story if no chapter ever shifts. You cannot describe a universe if nothing inside it has stepped into existence. So the first truth we must accept is this: time was waiting, not passing, not growing, not unfolding, just waiting, patient as a thought that has not yet formed. And in that waiting, something else was trapped: symmetry. A perfect kind of symmetry, the kind that allows no difference to arise, no choice to appear, no direction to break free. A symmetry so flawless that the universe could not decide what to become. Every possibility was equally balanced, equally available, equally unreachable. To us, symmetry sounds like harmony, but for a universe that needs variation to create form, symmetry is a prison. Inside that pristine stillness, nothing could begin, because everything was the same, identical in potential, identical in silence, identical in the way a sheet of calm water remains flat because every part of it is perfectly still. The universe was a mirror with no reflection, not yet alive, not yet empty, not yet anything, just a canvas without a painter, waiting for its first imperfection. But what does it mean for nothing to move? We live in a cosmos where motion is everywhere, so embedded into existence that we rarely question its origin. Electrons jitter even at absolute zero. Particles flicker with probability. Space itself stretches. Galaxies swirl. Black holes spin with fury. Motion is not rare. Motion is reality. Motion is the foundation of heat, light, gravity, time, and life. Yet the earliest version of reality held none of it. To understand this, you must soften your mind enough to step outside everything you think you know, not to reject knowledge, but to place yourself before knowledge existed. Picture a place where place is meaningless. Picture time without ticks. Picture a stillness so complete that sound could not form, because vibration had not been invented. In that stillness, there were no laws of physics, not because they were broken, but because laws require motion to express themselves. A rule that controls nothing is not a rule, it is a whisper in a room with no air. And so physics slept, fields slept, energy slept, potential slept. The universe was an unawakened thought. This is difficult to hold. We are creatures born deep inside a cosmos, addicted to motion. Our hearts beat, blood flows, eyes shift, thoughts race. Even in sleep, the brain thrums with electrical storms. We know no world without movement, but the universe once did. A universe where movement was not just absent, it was impossible. If you could drift backward through cosmic history, past the formation of stars, past the era of plasma and fusion, past the moment space inflated, past the fabric tearing itself into being, you would reach a threshold where our measurements collapse. Before that threshold, motion does not slow. It simply ceases to exist as a concept. There, in that invisible gulf, the idea of after becomes meaningless. The idea of before becomes weightless. The idea of location evaporates. Every future the universe might become lies dormant, like seeds waiting for the slightest tremor. But the tremor has not come. Stillness reigns, perfect, unbroken, immovable. This is not nothingness. Nothingness is already a concept. This is something more difficult. The absence of distinction, a state where nothing can be told apart from anything else, because no difference exists yet. A silence so vast it has no edge. A quiet so deep it has no depth. A moment so patient it has no duration. This is the canvas of creation, but not yet the act of creating. And then we reach the real mystery, the one that forces physicists into paradox and philosophers into contemplation. If the universe began without motion, why did motion ever appear? Why did the stillness break? Who or what made the first choice? What force had the freedom to act when action itself did not exist? The birth of motion is the birth of everything else. Energy, temperature, geometry, the arrow of time, the laws of physics, the first fluctuation, the first asymmetry. Without motion, nothing could become. With motion, everything began to seek its shape. But what was the first push? Was it random? Was it inevitable? Was it the first sign of imbalance? The first fracture in perfection? We cannot answer without stepping into the next chapter of this journey. But before we cross that threshold, stay a moment longer with the idea we rarely dare to imagine. Motion is not fundamental. It is not inherent. It is not given. It is not automatic. It is not a property the universe must contain. Motion is a consequence, a result, a response to something that changed inside the stillness. A stillness so complete that the smallest deviation, impossibly small, unimaginably faint, would unleash the first timeline in history. Here, in this early state, the universe is not a stage for events. It is a question waiting for an answer, and the answer arrives as a tremor. But that comes later. For now, let your mind settle into the emptiness that came before everything. A quiet without boundary. A stillness without center. A silence so absolute that even silence had not yet learned how to echo. The idea of a motionless universe challenges our deepest intuitions. We think of stillness as the absence of movement, but the stillness before motion is not an absence. It is a condition that has no opposite, because the opposite has not yet been invented. Without motion, energy cannot rearrange. Without rearrangement, structure cannot form. Without structure, laws cannot express themselves. Without laws, existence is only potential, never action. But potential without a spark remains asleep forever. You and I exist because that sleep eventually ended. We live inside the dream that followed. But before the dream, there was the breathless pause. And we, fragile inheritors of motion, can only return to it through imagination, through thought experiments that push us outside the physics we know, into the physics that once waited, untouched. And now, as you breathe, imagine the last thing before the first thing. Not darkness. Darkness requires contrast. Not cold. Cold is defined against heat. Not emptiness. Emptiness must be framed by the idea of fullness. Imagine a state beyond experience, yet containing the seeds of every experience that would one day arise. Imagine the universe before becoming a universe. It is here that the central question of this entire documentary lives. What broke the stillness? What force or flaw ended the perfect symmetry? What impulse opened the door for time to begin? What shift, buried inside nothing, made everything possible? You will hear many ideas: quantum fluctuations, field instabilities, broken symmetries. The first, imbalance. The first, vibration. But each of these is only a doorway. The deeper truth may lie further down the path, in a place where physics merges with something quieter and older than motion itself. Tonight, you step into that path, and as we leave this chapter, remember this: motion was not always here. It arrived, it emerged, it broke through the silence like a soft note on an untouched string. But before that note, before that break, before that tremor, everything was still, perfectly, impossibly, silently still. Close your eyes for a moment. Let the stillness wash over you, not as the end of movement, but as the beginning of meaning. Breathe slowly, because in the next chapter, we will ask the question that science cannot fully articulate and philosophy cannot fully contain. If stillness was the only law, why did it end? And what price did the universe pay to let motion in? The quiet waits, and we will follow it. But the silence didn't remain just a poetic image. It had structure, although not the kind we understand. What existed in that unmoving vastness was not emptiness, but a tension so perfect it erased itself. A balance so flawless it allowed no hierarchy, no priority, no opportunity for difference to appear. Imagine, for a moment, an ocean without surface. Not flat. Flat is already a description of shape. But an ocean where no wave could form, because no point within it is allowed to rise higher or lower than any other. An ocean so identical at every coordinate that even the word coordinate becomes meaningless. This is the stillness the early universe occupied. A state where every point was indistinguishable from every other point, not because they were equal in size or density or temperature, but because concepts like size, density, and temperature had no meaning yet. And the strange truth is that such perfection is not peaceful. Perfection resists creation. Perfection forbids direction. Perfection traps reality in a lock that cannot be opened from the inside. If the universe had remained perfectly symmetrical, perfectly still, perfectly unchanging, then nothing, absolutely nothing, would ever have existed. No stars, no galaxies, no laws. No here, no there, no you, no me, not even the concept of absence. The stillness was not a calm beginning, it was a cage. And if we try to step mentally into that cage, something inside our mind will instinctively push back. Because movement is embedded so deeply into our sense of reality that imagining its absence requires us to suspend the very machinery of perception. Your breath is emotion. Your heartbeat is emotion. Your awareness flickers from thought to thought, emotion. Even when meditation quiets your mind, neurons fire in delicate electrical dance, emotion. Even when you sleep deeply, the body shifts subtly, adjusting, drifting emotion. We cannot live without it. The universe, too, could not remain without it, though for a long span longer than measurement will ever reach it tried. The early stillness seemed stable because nothing inside it could interrupt itself. But stability and stagnation are not the same. The universe was not resting. It was waiting, waiting for something so small, so delicate, so improbable that it fractures the definition of probability itself. Because if the stillness was perfect, then nothing should have ever broken it. And yet something did. But before that fracture, before the universe learned to move, there was a property that defined everything: symmetry. Not the symmetry we see in crystals or snowflakes, not the symmetry of faces or flowers, but a symmetry so absolute that it made the entire cosmos indistinct, A symmetry where no point could claim difference, no field could tilt, no energy could lean. Symmetry, at this level, means no choice is possible, and the universe, in its first breathless state, could not choose. No direction, no orientation, no imbalance. Not even an impulse toward imbalance. Symmetry is beautiful when seen from afar, but terrible when you are trapped within it. The laws of physics that we know today, gravity pulling, quantum fields trembling, particles vibrating, cannot operate without difference. They require gradients, tensions, contrasts, deviations, unequal distributions. The universe had none. It held within it an infinite potential, but no mechanism to release it. It was a taut string that did not yet know what sound was, a blank page, unaware that stories could someday exist. And so the stillness continued, rigid, quiet, vast beyond imagination, yet featureless. A place where nothing moved because nothing could. But deep inside that frozen state, the ingredients of motion were already present, though dormant. Quantum fields existed not yet in activity, but in possibility, not vibrating, not fluctuating, not expressing, but present as a pure canvas. If you tried to name them, the names would be meaningless, because the phenomena those names describe had not yet occurred. Yet they were there. Think of a violin resting silently in a room. The strings exist. The body exists. Its capacity for music exists. Yet no sound has been played. The early universe held all the strings of physics, but no finger had touched them. This is the unbearable tension of the primordial stillness. Everything that would someday become reality was already encoded in it, trapped, motionless, unexpressed. A silent symphony waiting centuries, millennia, eons, before the first note. But why did the stillness last so long? And what counted as long when time had no way to pass? To say, before motion, is already misleading, because before implies sequence. There was no sequence. There was no progression. There was only a vast, undifferentiated presence. Inside that presence, nothing decayed because nothing existed. Nothing interacted because nothing could. Nothing emerged because emergence requires a break in the fabric. And yet somehow, the fabric would break, but not yet. Not for an unmeasurable expanse. During this age of stillness, the tension of symmetry became its own paradox. The universe was stuck in a state so perfect it could not escape, but also carrying a deep instability. Perfect symmetry is the most fragile thing in existence. The more perfect it is, the more catastrophically it can collapse when the smallest imperfection appears. And that imperfection eventually did appear, but its arrival was not explosive. It was not dramatic. It was not the fiery birth we imagine when thinking of cosmic origins. The first disturbance was faint, so faint that calling it faint exaggerates its scale. It was not a vibration. It was the ghost of a vibration. A possibility leaning slightly away from equilibrium, a lean so fragile that describing it can only be done metaphorically, because no physical model of today fully captures that proto-change. And yet that proto-change was enough. Because in a universe trapped in flawless symmetry, even the idea of imbalance, no matter how microscopic, can begin a cascade. Like a pencil standing perfectly upright. In theory, it could balance forever. In reality, the slightest breath, the tiniest shift in air, the gentlest vibration in the floor, collapses its symmetry and sends it falling. The universe before motion was the pencil. The first proto-change was the breath. But what is a breath in a cosmos without air? What is a shift in a world without movement? This is the mystery that physicists attempt to capture through the language of broken symmetry. A symmetry is unstable when it holds within it multiple possible outcomes, each equally likely. And when something, anything, nudges the balance, the universe snaps into one of those outcomes. The early universe did not choose chaos. It fell into it. like a pencil yielding to gravity. But the fall, the slip, the break, those belong to the next phase of our journey. Before we reach that first collapse, we must linger a little longer in the stillness, because the stillness holds a lesson that modern physics rarely teaches. The universe did not begin with action. It began with the inability to act. And this inability was not peaceful. It was suffocating. A potential so vast it could not express itself. The universe was not waiting for permission to move. It was waiting for a mistake, a flaw, a deviation, a whisper inside the silence. You are not hearing that whisper yet, not entirely. You are only feeling the tension building around it, the way your breath hesitates before releasing, the way quiet rooms feel full rather than empty. Before motion came meaning. Before meaning came possibility. Before possibility came stillness. And the stillness was not the opposite of motion. It was the soil from which motion would grow. But soil does not choose seeds. Seeds choose themselves. In the next breath of our cosmic story, something inside the stillness will crack. Something uncaused yet unavoidable. Something so small that calling it small misrepresents how delicate it truly was. The first hint of asymmetry, the first lean, the first tilt, the first preference. The stillness will not break loudly. It will not shatter like glass. It will slip quietly, subtly, into a new state. Stay close, because what comes next is the birth of the first tremor, and with that tremor, time will wake. What wakes first is not light, nor heat, nor expansion. What wakes first is an imbalance so slight that even calling it slight gives it too much shape. It is a deviation that cannot be measured, because measurement needs repetition, and repetition needs time. And time has not yet learned to unfold, but the deviation happens anyway. Inside the perfect stillness, so level, so uniform, so relentlessly symmetrical, there is a point where the universe cannot decide whether to remain what it is or to slip into what it could be. Not a location, because location is meaningless here. Not an event, because events require sequence. It is simply a state leaning infinitesimally away from itself. And that lean is the first thing in history to move. To understand its nature, you must imagine the quantum fields that underlie our universe today. Fields that fill all of space, electromagnetic, Higgs, gluon, neutrino fields, each of them restless, shimmering with zero-point fluctuations, even in the coldest possible vacuum. But in the primordial stillness, these fields already exist in a raw, undifferentiated form, not vibrating yet, not rippling, not expressing their identities, but present like instruments built before the idea of music. The Higgs field exists, but flat. The vacuum energy exists, but unengaged. The quantum potential exists, but dormant. And quantum mechanics, even then, carries a rule so deep it may be the oldest rule of all. Perfect symmetry is unstable. A surface that is too flat is ready to crack. A balance too perfect is ready to tumble. In mathematical terms, the early universe sits atop a false vacuum, a plateau where potential energy seems constant across all possibilities. But a plateau is not a valley. It is a place of hesitation where the smallest nudge can send everything sliding into a new shape. The nudge arrives without cause. It does not need a cause. Quantum fields do not require permission to fluctuate. They fluctuate by definition. Yet here, in the pre-motion epoch, that rule has no outlet until the very moment the stillness leans. It begins as a vacuum instability, a shift in the scalar potential, a whisper in the quantum foam, a microscopic asymmetry, so microscopic that the universe itself is still unaware it has changed state. But that first deviation breaks the symmetry, and when symmetry breaks, nature chooses sides. Suddenly, there is lower and higher. Suddenly, there is before and after. Suddenly, a direction exists. A direction defined not by space, but by falling energy. This is the hidden event at the center of all existence, the false vacuum decay. The stillness collapses, not violently, not explosively, but inevitably. As the vacuum transitions into a more stable state, the potential energy stored in that perfect symmetry is released. And that release is not gentle, it is the origin of the inflationary expansion that will later tear space apart faster than light. But for now, there is no expansion. Not yet. Only the collapse of stillness. A motion so small that it cannot be called motion by any language we use today. It is not a vibration. It is not a wave. It is the first preference, a bias in what had no bias. The Higgs field dips. The energy landscape tilts. The vacuum becomes uneven. And as soon as unevenness appears, motion becomes possible. Not actual motion, but the ability for motion. The mathematical permission for particles to have mass. The structural permission for forces to differentiate. The existential permission for time to acquire direction. This collapse is the seed of the Big Bang, though it does not yet resemble an explosion. It is the quiet flip of a universal switch. And from this point onward, everything that happens in the cosmos happens because of this first slip. Even now, billions of years later, every atom in your body carries the imprint of that moment. Your mass is a consequence of that tilt. Your heartbeat relies on electromagnetic interactions made possible by that tilt. Your thoughts ride on chemical signals shaped by that tilt. But in the early seconds of existence, the tilt is still new, still trembling, still choosing what rules the universe will obey. Fields that once sat perfectly still begin to wobble, not yet visibly, not yet with any rhythm, but with the earliest signs of potential instability. That wobble is the first breath of motion. In the modern universe, we call these wobbles quantum fluctuations. They create the seeds of cosmic structures. They sculpt the galaxies. They draw the map of the cosmic microwave background. But here, at the dawn of motion, they have no structure, no amplitude, no frequency. They are the trembling of a world awakening. The hidden event deepens. A slight tilt becomes a slope. A slope becomes a roll. A roll becomes a fall. And the universe, once trapped in symmetry, begins to fall toward its future. Time begins not as a stream, but as a possibility. Space begins not as distance, but as separation. Energy begins not as heat, but as escape from equilibrium. This is the moment physics opens its eyes. Every law we know, gravity, electromagnetism, weak and strong interaction, waits for the drop to finish. They hover, undefined yet inevitable, ready to crystallize as soon as motion becomes real. And motion is coming. It is still small, still almost imaginary, still clinging to the dying remnants of stillness. But it is coming. The universe no longer exists in a single state. The symmetry that once locked it into timeless perfection has fractured. The fracture widens. For the first time, the universe has an arrow. For the first time, there is direction. For the first time, there is change. And change, even the smallest kind, is motion's first shadow. Before motion appears fully, the cosmos experiences something even stranger, a phenomenon you can only grasp by setting aside everything familiar. The vacuum begins to fluctuate, as if remembering how to breathe. Not yet rhythmic, not yet patterned, but breathing. Like lungs, learning the first inhale after impossibly long stillness. Like water, trembling before the first wave. Like a string tightening before its first note. The stillness is ending, but not because something external arrives. It ends because perfection cannot hold itself forever. The quiet is learning to break. And you're here in the pause before that break widens into motion. Stay with it. Because what comes next is the first true vibration. A tremor that will define every star, every atom, every life form that will ever exist. The universe is preparing for its first movement. And when it arrives, everything will change. The shift grows, and with it, the fabric that once resisted all differentiation begins to loosen. What was a single, seamless state now trembles with the faintest hint of preference, so faint it would go unnoticed even if an observer existed. But there is no observer, only the universe noticing itself for the first time, the way a sleeper stirs before waking. That first tremor alters everything. The symmetry that once held the cosmos in perfect suspension buckles inward, like a taut sheet finally giving way. Not collapse in the dramatic sense, collapse in the mathematical sense, a transition from infinite sameness to the first flicker of distinction. Distinction creates consequence. Consequence creates sequence. Sequence creates the architecture of time. This is the moment time acquires direction. Not flow, flow comes later. Not speed, speed arises only when motion is measurable. Not duration, that requires clocks, processes, decays. But a direction, yes. A tilt from could be to is becoming. A slope from infinite potential toward definite expression. Only when the stillness breaks does time take its first irreversible step. And strangely, time does not begin as a river, it begins as a fall. A fall from instability into structure. A fall from perfect balance into uneven possibility. A fall that will never reverse, because the collapse of symmetry cannot be undone. The break widens. Vacuum energy pours out of the false equilibrium like water finding a crack in a dam. The landscape of potential dips, creating a valley where once there was only a flat plateau. And as the universe slides into that valley, its fields awaken. The Higgs field, once silent, finds a lower energy configuration and settles into it. This settling is not gentle, it is decisive, locking the character of particles into place. Mass becomes possible. Difference becomes real. Energy, no longer imprisoned in a perfect symmetry, learns how to rearrange itself. The fall accelerates. What was once still begins to shift, not through physical movement, but through the changing configuration of fields that define the nature of reality. This shift is motion in its most primitive form. And in this early turbulence, another profound transformation occurs. Space begins to stretch, not because something pushes it, and not because something inside it expands. Space stretches because the vacuum energy released from symmetry's collapse demands room to express itself. In general relativity, energy curves space-time. Here, the energy is not curving. It is forcing space-time outward, compelling it to grow. A universe that once resisted all distinction now begins to accelerate away from itself. This is not expansion as we imagine it today. It is expansion without boundary, without center, without direction. Every point becomes more distant from every other point, not through movement, but through the increasing separation of space itself. But even this expansion is not yet motion in the traditional sense. Nothing is moving inside the space. The space is moving. Matter does not yet exist. Photons do not yet roam. Particles have not yet danced. There is only the stretching of a fabric that has finally been freed from its perfect cage. And inside that stretch, the earliest forms of vibration awaken. Quantum fluctuations, once latent, become amplified by the expansion. A ripple the size of a subatomic realm becomes vast. A twitch in the vacuum becomes cosmic architecture. The tiny deviations amplified now will one day become the clusters of galaxies, the filaments, the voids. These fluctuations are the first genuine motion in the universe. Not motion through space, motion of space. Patterns that once could not exist now stretch into being. Regions of slightly different energy density begin to form. And from these differences, the universe acquires texture. Stillness is no longer perfect. The smooth ocean now has tiny swells. These swells are not yet waves, but they will be. And it is here, inside these subtle patterns, that time becomes measurable. Once you have change, you can track change. Once you can track change, you can compare moments. Once you can compare moments, you can define intervals. Time is no longer a slope. It is a direction with structure. The earliest clock in the universe is not ticking, but it is forming. A clock made of shifting energy, a clock built from the widening cracks of symmetry. A clock that does not count seconds, but counts transitions. Transitions are the currency of time, and the universe has just minted its first. The expansion surges, the fabric inflates so rapidly that distances double faster than light could ever travel. Not violating physics, because nothing is traveling through space. Space itself is expanding. Motion takes its first full breath. The breath is vast. The breath is irreversible. The breath is the first irreversible act the universe performs, and it sets the tone for everything that will follow. Irreversibility is the foundation of time's arrow. With symmetry broken, with expansion underway, with fluctuations amplified, the cosmos has committed to a direction, forward. And forward does not mean towards something. It means away from stillness. Every future moment is a step further from the symmetry that once held everything in suspension. Every unfolding physical process is a deepening of the wound opened by that first fluctuation. Every motion, from the orbit of planets to the firing of neurons, is a consequence of that step. Even now, every beat of your heart is a continuation of the first cosmic vibration. This truth can be unsettling. We are built on the ruins of stillness. The early universe does not mourn this. It does not look back. There is no back to look toward. But as the inflation continues, a new question grows quietly inside its momentum. If motion has now begun, can it ever stop? And if it cannot stop, what does that mean for a universe that once existed in perfect symmetry? Motion is beginning to define reality. It will shape every event, every object, every interaction. It will weave the fabric of causality. But deep in the expanding vacuum, there remains a trace, an echo of the stillness that came before. Not a remnant to be found, a remnant to be felt. The universe remembers its quiet origins not through matter or light, but through the tension that still exists between what it was and what it is becoming. A tension that will later manifest as dark energy, as expansion that refuses to slow, as the persistent push of space-time to grow, even when matter tries to hold it together. Even today, billions of years later, the cosmos expands not because of heat or pressure, but because of the same fundamental imbalance that broke the first stillness. Motion was not an accident. It was an inevitability once perfection cracked. And now, as inflation slows and particles begin to take shape from cooling fields, the universe prepares for the next step, the moment when motion becomes not just the fabric of expansion, but the behavior of things within it. Particles will learn to vibrate. Fields will learn to interact. Positions will learn to change. Clocks will learn to tick. But that transition, the moment when the universe stops being only motion of space and becomes motion in space, is the next threshold. And we are approaching it. Stay with this expanding quiet, because what emerges next is the first true particle in existence, and with it, the first true motion. The expansion slows, not because it wants to, but because the universe is cooling from the release of its first catastrophic imbalance. In the fading roar of inflation, the fabric that once stretched faster than any form of measurement can now breathe more gently. Temperature, once meaningless, begins to emerge in a language of averages and distributions. The fields that shape reality, Higgs, electromagnetic, strong, weak, start settling into the values they will hold for all cosmic time. Yet even in this cooling quiet, motion has not fully arrived. The universe has only learned how to stretch. It has not yet learned how to move within the stretch. Inside this vast, softening glow, energy condenses, not smoothly, not symmetrically. It pools in some regions, thins in others. The tiny fluctuations amplified by inflation begin to matter. They are no longer subtle ripples. They are the first scaffolding of structure. But structure does not yet mean solidity, because no particles exist. The fields haven't cooled enough to create entities, only possibilities. The vacuum is thick with potential, but not yet with things. What comes next is not explosive. It is delicate. The universe crosses a threshold of temperature where distinctions within fields harden into identity. At around this cooling point, though, point remains a metaphor. Because time is still in its infancy, the Higgs field relaxes into its final configuration. This is not a small change, but a profound collapse of freedom in the field landscape. Before this moment, everything, every proto-entity, every possible excitation had effectively no mass. They were expressions of motionless fields, not things with weight, not phenomena that could persist. And then, with the settling of the Higgs field, mass appears. Mass is not merely heaviness. Mass is permission for motion to be meaningful. Mass allows inertia. Mass allows resistance. Mass allows acceleration to have consequences. Without mass, motion becomes arbitrary, pure geometry, not behavior. With mass, the universe can finally begin to define what it means for something to move. The first particles form as the fields cool past critical thresholds. Quarks condense out of the hot plasma of pure energy. Gluons, carriers of the strong force, bind them together almost instantly. The strong interaction is so intense that quarks cannot exist freely for more than the smallest fraction of a rise, fraction of a second. They lock into pairs, triplets, forming the earliest hadrons. Protons will come later. Neutrons will come later. At this moment, everything is too hot, too wild, too unfocused for stable matter to exist. But the process has begun, and with it, the first genuine motion appears. Not motion of space, which defined the inflationary epoch, but motion in space. Quarks moving relative to quarks, gluons snapping between them, interactions, exchanging momentum, in a cosmos where momentum now matters. For the first time, direction within space has meaning. If something shifts slightly to the left rather than slightly to the right, that shift carries consequence. Mass gives it consequence. Structure gives it consequence. Interaction gives it consequence. Motion is no longer the stretching of nothingness. Motion is the dance of something real. Yet this dance is violent, chaotic, desperate. The early universe is still unimaginably hot. A furnace where particles slam into each other with energies beyond anything the most powerful colliders could dream of. But even in this chaos, there is an order forming, a choreography written by the new laws that crystallized from symmetry's collapse. Heat itself is a form of motion, microscopic motion, jostling motion, probabilistic motion. The universe is learning to express thermal movement, the distribution of kinetic energy among particles. This is not the kind of motion you can trace with a clear trajectory. It is motion as randomness, motion as agitation, motion as expression of temperature. And while this motion dominates, another quieter form begins to emerge, the first stable relationships between particles. As the universe cools further, quarks join into protons and neutrons. These are not stable forever, yet they transform freely through weak interactions, trading identities in a cosmic swirl of possibility. But these composites mark the beginning of endurance. Something can persist long enough now to be named. With persistence comes the ability to move not only as chaos, but as a pattern. In this era, motion begins to take shape as flows, as streams, as gradients. Places of slightly higher density pull in surrounding matter. Places of slightly lower density shed it. Though gravity is incredibly weak compared to other forces, it has one critical advantage: it accumulates. As the universe expands and cools, gravity begins to dominate larger scales. And gravity is the first force that creates directed motion, not jittering, not collision, not random trajectory, but attraction, consistent, predictable, irreversible directionality. Here, motion learns purpose. Tiny overdensities in the early cosmos start to grow, not dramatically, not suddenly, but inexorably. The amplified quantum fluctuations, stretched to cosmic sizes, now serve as blueprints for where motion will gather and where it will disperse. In the quieting furnace of the early universe, particles drift inward along gradients of gravitational potential. The drift is slight, barely noticeable in the rush of collisions, but it is constant, and constancy is the seed of cosmic architecture. For the first time, the universe's motion is not only internal but organizational. Motion begins to sculpt. The cooling continues. The cosmic temperature drops until protons and neutrons can bond into simple nuclei: hydrogen, helium, traces of lithium. Nuclear fusion erupts in microseconds of violent binding and breaking. But as the temperature drops further, even fusion becomes difficult. The universe becomes transparent to light. Photons decouple and begin their eternal journey through space. And with photons free to travel, motion expresses itself as the first rays of light to exist. Light is pure motion, motion untouched by mass, motion that ignores gravity's attempts to slow it. These photons, born from the searing glow of recombination, move not through the early plasma, but through the rapidly calming cosmic medium. Each photon is a line drawn through the newborn architecture of spacetime. Each photon is a witness to the birth of motion. Even now, more than 13 billion years later, those photons still travel. We see them as the cosmic microwave background. We detect their frequencies. We map their patterns. In their faint, stretched glow lies the memory of the universe learning to move. But the most profound emergence is yet to come. Once matter exists, once light flows, once temperature drops enough for forces to act without being drowned by heat, the universe approaches a new threshold. The moment when motion gives rise to structure in the truest sense, not on atomic scales, not on nuclear scales, but on cosmic scales. Gravity pulls matter into clumps. Clumps form clouds. Clouds collapse into stars. Stars ignite, fusing hydrogen into helium, releasing energy that travels as light, as heat, as stellar winds. Planets form in swirling disks of motion, dust spiraling inward until it becomes worlds. Everything becomes an expression of motion, expanding into form. But long before stars ignite, long before galaxies swirl, long before planets coalesce, the universe asks a quiet question, one as ancient as the first fluctuation that shattered stillness. Now that motion exists, what will it become? Will it become stable? Will it become chaotic? Will it create complexity or destroy it? Will it build or erode? Motion is no longer a subtle tremor, it is the defining principle of existence. And yet, in every dance of particles, in every swirl of gas, in every curve of space-time, a faint echo remains. The universe remembers the stillness that came before motion. That memory hides in the concept of inertia, the resistance to change, the ghost of the moment when change was impossible. It hides in the fabric of space-time, which seeks symmetry even as motion breaks it. It hides in the persistence of physical laws that once crystallized from perfect balance. But the memory is fading. Motion has taken hold. Motion governs. Motion sculpts. Motion endures. And as the universe continues to cool, as matter gathers into the earliest clouds, a new kind of motion emerges, no longer merely thermal, or gravitational, or quantum, but organized rotation. Gravity pulls matter inward, but small asymmetries create spin. Conservation of angular momentum ensures that collapse leads to rotation. Rotation is the first cosmic choreography, a motion that persists across billions of years. From this rotation, galaxies will one day form. From galaxies, stars. From stars, planets. From planets, chemistry. From chemistry, life. From life, consciousness. From consciousness, the awareness that motion once did not exist, All of it, every future world, every living thing, every thought, will trace its ancestry to that microscopic deviation in the primordial stillness. The universe has learned how to move, and it will never stop moving again. Not until the far future, where motion may fade, where expansion may slow or accelerate into oblivion, where particles may decay, where temperature approaches absolute zero once more. But that is another horizon. For now, motion grows. Motion deepens. Motion becomes the language of existence, and the stillness that came before it becomes only a memory, quiet, unreachable, but foundational. The universe is awake, and its first steps echo across eternity. As rotation becomes the quiet heartbeat of collapsing clouds, the universe enters its first era of patterned motion. These patterns are not yet elegant spirals or glowing disks. They are uneven, trembling, fragile, but they persist. And persistence is the first sign that motion is no longer an accident of symmetry breaking, but a property the universe has learned to maintain. Across the expanding cosmos, matter begins to drift into regions of slightly higher density. These regions do not attract, because attraction is a choice. Gravity is not a choice. It is the curvature of space-time itself, deepening beneath the weight of newly formed mass. And as mass pools, motion becomes directional, like water flowing toward depressions in land. The earliest flows are slow, incredibly slow by the standards of the later universe, but they are steady. They are the first long-distance journeys matter ever makes. These flows amplify the fluctuations left behind by inflation. The tiny overdensities, once no more than statistical wrinkles, grow into gravitational wells, and as they deepen, the motion of matter accelerates. Motion now feeds on motion. The more matter moves inward, the more gravity strengthens. And the more gravity strengthens, the faster matter pours in. It is a cycle that will shape the cosmos for billions of years. Within these growing wells, turbulence emerges, not chaos in the human sense, chaos in the mathematical sense, where tiny initial differences become vast divergences over time. Turbulence arises because the universe is not perfectly smooth, because matter collapses in uneven bursts, because temperature varies, because the early cosmos still carries scars of the symmetry that shattered it. These scars ripple through the collapsing clouds, creating eddies, whirls, and shocks. Motion is beginning to layer itself into complexity. As these layers accumulate, motion develops not only speed, but intention. Not conscious intention, but structural intention. The tendency for matter to align, to orbit, to stabilize around the center of gravitational collapse. From this alignment, the first real disks form. They are not yet galaxies, but proto-galaxies, dense, spinning vortices of hydrogen and helium, swirling in gravitational embrace. Inside these whirlpools, new forms of motion ignite. The collapse of gas heats the interior. Temperature is motion. Heat is motion. The higher the temperature, the more desperate the motion becomes. In the core of these clouds, where density climbs and pressure rises, the motion becomes so intense that hydrogen nuclei begin to collide with enough force to overcome their natural repulsion. Nuclear fusion begins, not gradually, but suddenly, in flashes of brilliant release. And with fusion, the universe receives its first sustained sources of internal light. The first stars ignite. Their ignition is not a silent event, though the cosmic vacuum carries no sound. Motion inside the core becomes so rapid that it transforms mass into energy. Energy radiates outward as photons, neutrinos, and charged particles. These photons scatter inside the dense stellar plasma, bouncing trillions of times before escaping to space. When they do escape, they become the first beams of starlight in a universe that was once pure darkness. Starlight is motion carried across vast emptiness. It is motion that persists for billions of years, without slowing, without aging, without forgetting where it began. With the first light, motion acquires memory. Photons become the storytellers of physics, traveling through the young cosmos, recording the expansion of spacetime in their lengthening wavelengths. As stars form across the earliest clusters, the architecture of the universe matures. But while gravity organizes matter at large scales and fusion drives motion at stellar scales, another layer of motion emerges: the motion of atoms within stars, the churning convective flows that transport heat, the rotational spin of the young star itself. Stars spin because the clouds they formed from spun. Angular momentum never disappears. It redistributes, strengthens, or weakens as collapse proceeds, but it does not vanish. And so, each young star inherits a motion that predates it, a motion that began when matter first fell inward under gravity's quiet pull. Around these stars, disks of dust and gas gather. These disks, too, rotate, flattening under centrifugal force, cooling into regions where heavier elements born inside the nuclear furnaces of the first stars can condense. These disks are the birthplace of planets. But before planets can arise, the universe undergoes another transformation, one even more subtle than the birth of stars, yet crucial to the evolution of motion. In the plasma seas of early galaxies, matter collides in ways that generate magnetic fields. As electrons and ions move, their motion creates currents. Currents create fields. Fields influence motion again. Magnetic fields survive, grow, twist, stretch, and reconnect. They sculpt the flows of gas, drive jets from young stars, and thread through the cosmic web like invisible strands of tension. Magnetic fields give motion a new layer of coherence. They guide particles. They restrict their paths. They accelerate them. They create spirals and loops where before there were only straight lines and collisions. Magnetism is motion organizing itself into structure. The early universe becomes a theater of dynamic interactions: shock fronts, radiation pressure, stellar winds, supernova disturbances. Each of these phenomena expresses motion in a different form, and when the first massive stars end their lives, motion becomes violent gravity crushing their cores into neutron stars or black holes, while their outer layers are thrown into space with unimaginable force. Supernovae represent the universe's first great push outward. They scatter heavy elements across space: carbon, oxygen, silicon, iron, the seeds of future planets, the seeds of life. Their motion carries meaning, shaping the chemistry of worlds that do not exist yet. As time progresses, galaxies form in greater numbers. They orbit around each other, merge in slow cosmic dances lasting billions of years. During these mergers, stars rarely collide, but their orbits shift dramatically. Some are flung out into intergalactic space, others fall toward the galactic center. Gas clouds crash and compress, triggering waves of new star formation. Motion now governs history. Motion now shapes destiny. Meanwhile, on smaller scales, planets begin to emerge. Dust grains collide and stick. Pebbles gather into rocks, rocks into boulders, boulders into protoplanets. Gravity compacts them into spheres. Some orbit close to their stars and become scorched deserts. Others orbit farther out, forming icy shells. Some worlds retain thick atmospheres. Others lose them in stellar winds. Finally, on at least one of these worlds, motion becomes something entirely new: metabolism. Chemical reactions self-organize into cycles that harness motion, motion of electrons, motion of molecules to persist. Life is born not from stillness, but from sustained internal motion. Cells use motion to divide. Organisms use motion to seek energy. Evolution uses motion to explore possibilities. And billions of years after, the first fluctuation shattered perfect symmetry, a creature emerges that can contemplate motion itself. A mind built from electrical signals, synapses, neurotransmitters, each a form of motion at microscopic scale. A mind capable of recognizing that its own awareness depends entirely on the trembling of matter that once did not move. In this creature's lifetime, countless motions occur. Stars orbit the galaxy, planets rotate, atoms vibrate within every breath. Motion has become so fundamental that imagining its absence feels impossible. Yet the memory of the universe knows otherwise. That memory is not stored in matter. It is stored in the laws of physics, in the inertia that resists change, in the geometry of space-time that forever carries the imprint of its earliest expansion. The universe today still expands, not as violently as during inflation, but steadily. Dark energy pushes galaxies apart. Large-scale structures drift farther away. Motion has become so integral to the cosmos that even the empty vacuum accelerates. But beneath this constant motion lies a truth older than stars, older than galaxies, older than the first particle that ever formed. The universe once existed in a state where motion was impossible. Everything that exists now, every world, every star, every heartbeat, every orbit, emerged from that impossibility. And the echoes of that stillness remain, not in the silence of space, but in the laws that define motion's limits. In the notion that nothing can exceed the speed of light, the cosmic speed limit that emerges from the structure of space-time itself, even this limit is a reminder that motion grows from constraint, from the boundaries imposed by the earliest conditions. As we look across the cosmos, we witness motion in its most stunning forms. The rotation of galaxies stretching into spirals, the dance of gravitational waves rippling from colliding black holes, the drift of cosmic rays traveling for millions of years before touching an atmosphere. Motion has become the sculptor of everything. Yet the memory of stillness lingers at the edges of the universe's imagination, whispering that one day, far into the future, motion might fade again. When stars exhaust their fuel, when black holes evaporate, when particles decay, when expansion stretches space so thin that interaction becomes impossible, motion may slow until it resembles the quiet that once existed before time. But that end is distant. For now, motion thrives. It grows. It organizes. It becomes complexity, then chaos, then order, then consciousness. The universe continues to move, and every movement is an echo of the moment it first learned how. As the universe matures into its first billion years, motion becomes not only common, but inevitable, woven into every scale of existence, from the trembling of quantum fields to the rotation of superclusters. Yet beneath this tapestry of motion lies a subtle truth. Motion is no longer simply occurring, it is being shaped, refined, regulated by the forces that emerged from symmetry's original fracture. The cosmos is not merely moving, it is learning how to move with patterns that will endure across cosmic timescales. On the smallest scales, particles dance ceaselessly. Electrons orbit atomic nuclei, not as tiny planets tracing fixed paths, but as probability clouds shaped by wave functions. These wave functions spread, interfere, collapse, reform, each process a different form of motion. Quantum mechanics ensures that motion is never truly still, even at absolute zero, because zero-point energy keeps every particle trembling. The memory of the universe's first movement echoes in the jitter of electrons and the oscillations of fundamental fields. As molecules begin to form in the cooling remnants of early stars, chemistry emerges as another layer of structured motion. Chemical bonds vibrate, rotate, stretch, and release. Reactions proceed through collisions, guided by temperature and probability. Even the difference between life and non-life hinges on motion. Living systems sustain organized flows of energy and matter, maintaining order in defiance of entropy by exporting disorder into their surroundings. Life is the universe's way of sculpting motion into persistence. Meanwhile, on scales far larger than molecules, stars gather into the structures that will define the future of cosmic evolution. Groups of stars orbit around shared centers, forming globular clusters and stellar associations. These orbits are not random. They reflect the initial conditions set by the gravitational collapse of gas clouds. A star's trajectory around its host galaxy can span hundreds of millions of years, yet it follows a path that began with the first whispers of motion in the primordial universe. Galaxies themselves become masterpieces of movement. Spiral galaxies spin, their arms trailing behind like luminous whirlpools. Elliptical galaxies swarm with stars in random motions, ancient remnants of violent mergers. Irregular galaxies twist and contort, shaped by tidal forces and collisions. Each galaxy, regardless of its form, carries in its core a supermassive black hole, a gravitational anchor whose influence extends across hundreds of thousands of light years. Around these dark leviathans, stars orbit with exquisite precision, obeying the curvature of space-time. Black holes introduce a form of motion that is unlike any other. As matter spirals into a black hole, it forms an accretion disk, a glowing, turbulent ring of plasma moving at nearly the speed of light. The motion here is so extreme that time itself slows. Photons struggle to escape, bending, stretching, reddening as they climb out of the gravitational well. Jets shoot outward from the poles, blasting particles across intergalactic distances. These jets are among the fastest, most energetic motions in the universe, and yet they originate from regions no larger than a solar system. Motion becomes encoded in the very geometry of space-time. Massive objects warp their surroundings, dictating how matter and light must move. Gravity is not a force pulling objects together. It is the shape of the stage on which all motion unfolds. Every orbit, every trajectory, every fall is a path traced through this curved geometry. Even gravitational waves, ripples in space-time created by accelerating masses, are a pure form of motion, traveling across the cosmos at the speed of light, carrying with them the imprints of cataclysmic events long past. As galaxies continue to merge, the cosmic web grows more intricate. Filaments of dark matter, invisible scaffolding that shaped the universe from its earliest days, guide the movement of galaxies, pulling them along gravitational highways. Voids expand between these filaments, vast bubbles where matter is scarce and motion slows. In these enormous emptinesses, galaxies drift quietly, carried only by the residual expansion of space. Even here, motion cannot be escaped. The universe itself continues to stretch, and galaxies move with it. But perhaps the most profound transformation in motion comes not from stars or galaxies, but from the emergence of systems capable of internal complexity. On planets cooled enough to sustain stable chemistry, motion organizes into cycles. Water evaporates, condenses, flows. Tectonic plates shift, atmospheres swirl, with storms driven by thermal gradients. Oceans churn under the push of wind and rotation. These planetary motions are the first seeds of environments where even more intricate forms can grow. And in at least one place, on at least one world, motion becomes thought. It begins with molecules that organize into self-replicating structures. Harnessing energy to maintain their order, these structures evolve into cells that swim, crawl, divide. Each act of life is an act of motion, a defiance of stillness. Over billions of years, these cells diversify, forming organisms with beating hearts, flowing blood, electrical networks capable of coordinating movement. The nervous system represents a new frontier in cosmic motion. Motion as information. Neurons fire, ions flow, electrical potentials rise and fall. A neuron's firing is a ripple, a wave, a transformation of energy into meaning. When many neurons fire together, patterns emerge. When patterns connect, awareness arises. And when awareness becomes self-referential, consciousness emerges. Consciousness is motion folded inward. Thought is motion carried along neural pathways. Memory is motion stabilized into structure. Perception is motion interpreted through sensory organs that evolve to detect the universe's moving patterns. light waves, sound waves, vibrations, chemical flows. Even emotion is motion, shifts in internal chemistry shaping actions and reactions. The universe, in these minds, remembers itself. It remembers that motion was once impossible. It remembers not through words or symbols, but through the structure of the laws that govern it. Every physical limitation, every constant, every behavior flows from the original moment when symmetry fractured and motion began. The curvature of space-time, the quantization of energy, the constancy of the speed of light, the behavior of matter under heat or pressure, each law is an echo of the first motion. Yet the story of cosmic motion does not end with life. It continues to evolve on even larger scales. As eons pass, galaxies drift farther apart due to the acceleration driven by dark energy. Motion now stretches not only matter, but the emptiness between matter. The cosmic expansion that once slowed under gravity's pull now accelerates, driven by a mysterious energy that fills space uniformly. This acceleration ensures that distant galaxies will one day slip beyond the cosmic horizon, moving away faster than light can bridge the gap. Their light will never reach us. Their motion becomes eternal separation. In the far future, after stars exhaust their fuel and galaxies dim, motion will slow on local scales. The universe will cool, and particles will decay. Black holes will evaporate through Hawking radiation, releasing their mass as faint whispers of heat. Motion, once the defining feature of reality, will gradually fade as entropy rises and usable energy declines. Yet even in this distant future, motion cannot be erased entirely. Quantum fluctuations will continue, faint and rare, but persistent. Zero-point energy will remain the last heartbeat of a universe that once surged with dynamic structure. The cosmos will not return to the perfect stillness that preceded its birth, because motion has carved too deep a mark into the laws of physics to be undone. Stillness may approach, but never fully arrive. Motion, once born, never truly dies. And in the faint glow of the final particles drifting through near-empty space, the memory of the universe's first trembling survives. It survives in the laws that have governed every event since the beginning, in the structure of space-time, in the patterns of quantum interactions. The universe continues to move because motion is now what it is made of. From the first trembling in the vacuum to the swirling of galaxies, from the beating of hearts to the firing of neurons, from the drift of photons across billions of years to the dance of electrons, inside atoms, motion defines existence. The stillness before motion was the canvas. Motion is the painting. We are part of that painting, made of the same trembling fields that once broke the silence. And as long as any part of the universe continues to express energy, as long as any field retains fluctuation, as long as any particle persists, motion will endure quietly, elegantly, inevitably. The universe has not stopped moving since the moment it learned how, and it never will. Motion becomes the quiet engine of everything the universe will ever attempt, yet it is still far from reaching its full maturation. Even in the age of galaxies and stars, motion is young compared to the vast future awaiting the cosmos. But to understand where motion is going, the universe must first navigate the consequences of its earliest choices. These choices are written not in words, but in the laws that emerged from the primordial fracture. And those laws now guide the evolution of motion through phases, as subtle as quantum transitions and as vast as cosmic expansion. On the quantum frontier, particles continue to flicker between states with a restlessness that never fully ceases. Electrons shift in orbitals. Photons exchange momentum with atoms. Quarks jitter inside protons. The universe's earliest breath of fluctuation is now embedded in the smallest units of matter. Every vibration of a molecular bond, every absorption of a photon, every spontaneous emission that sends a particle cascading into a lower energy state is an echo of that first trembling. Even the uncertainty principle itself, a rule that states one cannot know a particle's position and momentum, simultaneously ensures that motion cannot ever be perfectly still. Stillness is forbidden. Motion is required. But quantum motion, though foundational, is not the only legacy of the early universe. On cosmic scales, motion organizes into flows that reveal the deep structure of space itself. The cosmic web stretches in all directions, filaments of matter extending millions of light years, connecting clusters of galaxies into a structure so large that human imagination struggles to grasp it. These filaments are not static, they pulse with the movement of galaxies falling toward their shared centers of mass. The fall is slow, measured in billions of years, but it is inexorable. Gravity tugs at these galaxies, like faint threads pulling beads along invisible lines. As galaxies move, the dark matter halos that cradle them shift as well. These halos, made of particles we cannot see, define the gravitational boundaries within which stars and gas dance. The motion of dark matter is silent, without radiation, without interaction, except through gravity. But its silence does not diminish its influence. Dark matter guides the movement of luminous matter the way a hidden riverbed guides the water flowing above it. The currents of galaxies are shaped by the unseen architecture of dark matter, and so motion becomes a way of revealing what cannot be directly observed. In the interiors of stars, motion becomes pressure, the balance between inward gravitational collapse and outward thermal expansion defines a star's lifespan. For billions of years, stars churn hydrogen into helium, helium into heavier elements. This nuclear burn is organized motion, regulated by quantum tunneling and sustained by the immense energies trapped within atomic nuclei. If motion were to slow even slightly at the quantum level, stars would not shine. If motion were to accelerate catastrophically, stars would tear themselves apart. Stability is a delicate equilibrium of motion, a perpetual dance between collapse and eruption. In planets, motion manifests as weather, magnetism, and geology. Atoms vibrate within rocks. Molten cores swirl beneath crusts. Tectonic plates drift as continents rearrange over tens of millions of years. These motions rewrite the identities of worlds. Without motion, planets would be dead spheres of static matter. With motion, they become landscapes of storms, oceans, mountains, and atmospheres, each an expression of underlying thermal and gravitational gradients. On Earth, motion becomes life. Life isn't only motion. It is motion organized for the purpose of persistence. Cells pump ions across membranes, synthesize molecules, divide in orchestrated cycles. Proteins fold and refold in fluid motions, carrying out tasks essential to all living processes. Even the genetic code itself depends on molecular movement enzymes sliding along DNA strands, ribosomes reading RNA sequences in rhythmic cycles, molecular motors carrying cargo along cytoskeletal tracks. The complexity of life intensifies as organisms develop nervous systems. Here, motion becomes coded into electrical patterns, allowing for reflexes, behaviors, instincts. Sensory organs evolve to detect the motions of the world: light, sound, pressure, chemicals carried by air or water. In this way, motion is not only experienced, but interpreted. The universe, through living systems, begins to perceive its own dynamism. Eventually, intelligence arises, another milestone in the story of motion. Intelligence is motion refined into abstract structure. Thoughts are patterns of electrical activity. Memories are pathways reinforced by repeated pulses. Decisions arise from cascades of signals traversing neural networks. When a mind contemplates the cosmos, it is motion contemplating motion. When a mind imagines the stillness that existed before motion, it is motion imagining the absence of itself. As intelligent civilizations observe the sky, they begin to detect motions far beyond their planet. Stars drifting through the galaxy, planets orbiting suns, galaxies receding with cosmic expansion. Telescopes capture the light of ancient stars whose photons have traveled billions of years, carrying the imprint of motion across time. The universe becomes a grand documentary of motion unfolding across scales and ages, and consciousness becomes its archivist. But even as life evolves and civilizations rise, the universe's long-term motion continues to change. Expansion accelerates. Galaxies that are bound together remain bound, but those separated by vast distances drift farther away until their motion exceeds what light can cross. The observable universe shrinks in relative terms, not because matter is disappearing, but because the horizon of what can be reached grows narrower. Galaxies vanish over the cosmic edge, leaving behind a quieter, more isolated cosmos. In this future, motion shifts again. Stars age and die. White dwarfs cool into black dwarfs. Neutron stars radiate their remaining heat into the void. Black holes slowly evaporate, releasing faint streams of radiation as space-time itself unravels their mass. Motion becomes sparse, faint, rare. The universe dims into a horizon where the drama of motion gives way to the whisper of quantum fluctuations, the final echo of the first motion. Yet even here, motion does not fully extinguish. Zero-point energy remains, the irreducible trembling that no cooling can erase. Even in a dark, empty cosmos, particles can spontaneously appear and vanish through quantum foam. These tiny events are the distant descendants of the first instability that shattered perfection. Zero-point motion is the last heartbeat of reality. The cosmic end state is not frozen stillness, but a thin, quiet trembling that persists because the laws born at the beginning cannot be undone. The universe never returns to perfect symmetry. Perfect symmetry cannot hold once it has been broken. The memory of the original imbalance is carved into the structure of fields and forces, and so motion endures in the smallest possible way, even when all else has faded. Thus, the story of the universe becomes the story of motion's rise, maturation, and long descent into quietness, but never into silence. Silence, true silence, belongs only to the state before motion began. And across the entire timeline of existence, from the first trembling of the vacuum to the last quantum flicker trillions of years from now, the universe never again touches that perfect stillness. Motion, once born, carries eternity within it. The particles in your body, your breath, your pulse, your thoughts, all participate in this ancient motion. Every atom within you vibrates with frequencies established by the laws formed during the universe's earliest moments. Every heartbeat, every inhale, every flicker of awareness is a continuation of the first motion that broke the silence before time. You are not simply made of matter, you are made of movement. You exist because the universe refused to remain still. And so, as you breathe now, you become an expression of that primordial decision. You carry within you the story of a cosmos that once lay in perfect symmetry, unmoving, unbroken, and the story of how that stillness fractured into everything. The universe is still moving, and as long as you are alive to witness it, you are part of that motion, an echo of the moment the cosmos first woke from stillness. As the universe continues its vast migration through time, motion evolves yet again, not by becoming faster or more chaotic, but by refining itself into the subtle dynamics that govern all transformations. What began as the trembling of a vacuum, as an instability too delicate to name, has matured into an intricate hierarchy of movements, from the restless jitter of quantum fields to the majestic drift of galaxies across cosmic horizons. But beneath every scale of motion lies a deeper question. What does it mean for the universe to move, when the universe itself is the reference frame of all movement? This question unfolds slowly, like a thought the cosmos has spent billions of years learning to articulate. To begin answering it, motion starts to manifest not only as spatial change, but as transformation in state. Particles that once behaved simply now reveal layers of complexity. Electrons tunnel across barriers without crossing the space between. Neutrinos oscillate between identities as they travel through the void, shifting their very nature with each moment of flight. Quarks and gluons inside protons churn with frenetic energy, confined by the strong force into patterns too fast to resolve. These internal motions carry no macroscopic movement, yet they are motion nonetheless. Motion of identity, motion of probability, motion of fundamental properties. As the universe cools further, a new form of motion arises from the decay of unstable particles. Some transform into lighter species, releasing energy that ripples through space. Others annihilate with their antiparticles, producing photons that will travel unhindered forever. These decays populate the universe with light, with heat, with radiation that continues to fill the cosmic microwave background we observe today. Motion has become the means by which the universe transfers information about its past into its present. On the scale of galaxies, motion becomes sculpture. Gravity draws matter into halos, into clusters, into great interconnected rivers of stars that stretch for millions of light years. These structures are not rigid. They twist, they coil, they evolve as galaxies interact. Some drift gently past one another, their shapes subtly altered by tidal forces. Others collide head-on, merging in dramatic bursts of star formation and reshuffling billions of stars into new configurations. The collision itself is slow, so slow that from a human perspective, it would seem frozen in time. But at cosmic scale, the motion is undeniable, sculpting entire galaxies into new forms. Within galaxies, motion becomes rhythm. Stars orbit the galactic center, tracing paths determined by the combined gravitational pull of visible matter and dark matter. These orbits are not perfect circles. They are ellipses, spirals, chaotic loops, shaped by gravitational resonances and perturbations. Some stars are flung outward into the galactic halo, drifting alone through sparsely populated regions. Others spiral inward, interacting with dense molecular clouds, occasionally plunging into star-forming regions where motion becomes turbulence, heat, and pressure. Meanwhile, inside stars, nuclear reactions churn with extraordinary intensity. Hydrogen nuclei overcome their repulsion to fuse into helium, releasing energy that travels outward as radiation. The journey of this energy is itself a form of motion, not a smooth path, but a chaotic random walk, as photons bounce through layers of plasma, colliding millions of times before escaping the stellar surface. When they finally emerge, they travel across space as beams of light, carrying with them the story of their long journey through stellar interiors. Surrounding stars, planetary systems form through motion initiated by dust and gas spiraling within protoplanetary disks. Collisions between grains create pebbles. Collisions between pebbles create rocks. Over time, gravitational focusing allows these rocks to accumulate mass, growing into planetesimals, then protoplanets. Motion governs every stage. Collisions determine growth. Orbital resonances determine spacing. Angular momentum determines stability. As planets reach maturity, they settle into orbits that persist for billions of years, their paths shaped by the balance between gravitational pull and orbital velocity. On some of these planets, motion evolves into climate systems driven by stellar energy. Winds flow from high-pressure zones to low-pressure zones. Oceans circulate heat around the globe. Storms form, grow, and dissipate. These motions shape the surface and atmosphere of each world, determining its temperature, chemistry, and habitability. Without motion, planets would be silent, static spheres, lifeless and unchanging. On Earth, motion becomes the essence of life itself. Chemical reactions within cells depend on the motion of molecules, the diffusion of nutrients, the flow of ions across membranes. Proteins fold into shapes determined by molecular vibrations. Enzymes catalyze reactions through carefully choreographed motions at the atomic level. Even DNA replication depends on motion enzymes, unwinding the double helix, polymerases, sliding along strands, bases snapping into place through dynamic interactions. As organisms evolve, motion becomes behavior. Microbes swim toward nutrients or away from toxins. Plants grow toward light, their cells expanding and contracting through internal motion, driven by water pressure. Animals develop muscles, skeletons, nerves, all systems dedicated to creating and controlling motion. The evolution of limbs, wings, fins, and muscles allows life to explore new environments, expand its reach, and develop new strategies for survival. Eventually, motion becomes perception. Eyes detect the movement of photons. Ears detect the vibration of air molecules. Skin detects pressure and heat. Sensory organs become pathways through which organisms interpret motion at every scale, from ripples on water to the movement of stars across the night sky. Perception allows organisms not only to move, but to anticipate motion, to react, to plan. This leads to the emergence of minds capable of understanding the universe's dynamism at ever deeper levels. Human consciousness takes this understanding further. Minds reflect on the motions of planets, the cycles of seasons, the rhythm of life and death. Through mathematics and physics, humans uncover the principles governing motion, from Newton's laws describing predictable trajectories to quantum mechanics revealing probabilistic motion at the smallest scales. Humanity discovers that motion is not just an attribute of matter, but a manifestation of the fabric of reality. As telescopes peer deeper into space, humans find motion encoded in every photon. The redshift of distant galaxies reveals that space itself moves, stretching over time. This discovery leads to the startling realization that the universe is expanding and that the expansion is accelerating. This acceleration, driven by dark energy, represents a final evolution in the story of cosmic motion. It is motion without force, without direction, without friction. It is motion encoded in the very geometry of space-time. The future of the universe continues this trend. As galaxies accelerate away from each other, motion becomes isolation. Cosmic structures drift beyond one another's horizons. The night sky darkens as fewer galaxies remain visible. Stars exhaust their fuel and collapse into white dwarfs, neutron stars, or black holes. Over unthinkably long timescales, even these remnants decay. Black holes evaporate, leaving behind only a thin bath of radiation. Motion slows, dims, fades, but it never vanishes entirely. Quantum fluctuations persist, a faint trembling of the vacuum that no cooling can erase. These fluctuations are a reminder that the stillness before motion, the perfect symmetry of the primordial universe, can never return. The symmetry was broken, and the universe cannot unbreak it. In the end, motion becomes the thin trembling that threads through nearly empty space. The universe grows cold, dark, quiet, but not still, never still. The laws that govern reality forbid absolute stillness. Motion remains, even as the cosmos enters its twilight. And this faint motion, this final whisper, is the echo of the first tremor that transformed perfection into possibility. When you breathe, the molecules in your lungs follow patterns encoded in the earliest laws of physics. Your heartbeat is the rhythmic contraction of cells driven by ions flowing across membranes. Your thoughts are electrical impulses traveling through networks of neurons. You are motion arranged into awareness, your body a vessel for motion, your mind a pattern of motion, your existence a continuation of the moment the universe first chose to move. Motion is not something you observe. Motion is something you are made of. Motion is the memory of the universe living through you. And if you close your eyes now and let your breath fall into a slow, even rhythm, you may feel not as a thought, but as a sensation, the quiet truth that connects you to the first trembling of the vacuum. The universe moves in you, and you move in the universe. The silence before motion is gone forever, but its echo follows you, softly, in every breath you take. As the universe continued expanding and cooling, the nature of motion itself underwent a transformation more profound than any before it. Motion had begun as trembling, as instability, as the jitter of quantum fields trying to escape perfect symmetry. It had grown into the swirling of gas clouds, the rotation of stars, the merging of galaxies. But none of these were yet the most fundamental expression of motion. Beneath all of it, the stage on which motion played, space itself was beginning to change. Space was no longer simply the backdrop against which matter moved. Space itself was learning to move. When the earliest galaxies formed, they did not drift apart because of their own velocity alone. They moved apart because the space between them was stretching, expanding, pushing them away from one another. In this era, the expansion of space had slowed drastically from its inflationary burst, yet it still continued with a steady, unstoppable rhythm. The galaxies were passengers on a sea that refused to remain still. This movement was not a consequence of objects pushing off each other. It was the expansion of the medium they inhabited. Space is not empty. It is not passive. It is not inert. Space is a dynamic field with tension, elasticity, and curvature. The presence of matter deforms it, but even when matter is absent, space has its own behavior. The cosmological constant, a small but non-zero energy density, filling all of space, ensures that expansion never stops. Even when galaxies bind together under gravity, forming clusters and superclusters, the vast voids between these structures grow larger. As billions of years pass, galaxies become isolated islands in an expanding ocean. This expansion is subtle at small scales. Within galaxies, the pull of gravity is strong enough to bind stars together. In clusters, the collective mass binds dozens or hundreds of galaxies. But beyond these islands of structure, expansion reigns supreme. The further apart two galaxies are, the faster they recede from one another, not because of their motion, but because of the stretching of the space between them. This shift in the nature of motion changes everything. Motion no longer depends only on force. Motion can now arise from geometry. The curvature of space-time, determined by matter, energy, and the mysterious dark energy, dictates how galaxies drift, how light travels, how the universe evolves. As space learns to move, motion begins to shape not only the distribution of matter, but the horizon of what can be known. Distant galaxies slip further away, their light stretched into longer wavelengths. What was once visible becomes infrared, then microwave, then radio. Eventually, these galaxies fade beyond the cosmic horizon. Even if they continue to exist, their motion, carried by the expansion, prevents their light from ever reaching our region again. Motion creates isolation. The universe that once was small enough for every region to influence every other becomes fragmented. The cosmic web that binds galaxies remains intact locally, but its global structure drifts apart. Superclusters separate into lonely islands. The space between them grows cold, dark, and silent. Within these islands, motion follows different rules. Gravity forms the intricate architecture of galactic life. Rotational curves flatten as dark matter exerts its unseen influence. Stars orbit their galactic center in a delicate balance between velocity and gravity. But even within galaxies, there are signs that space is not just a neutral backdrop. Near massive objects like black holes, space curves dramatically. A star passing too close to a black hole experiences tidal forces strong enough to tear it apart. This is motion sculpted by geometry, motion imposed by the way mass shapes space-time itself. Where space bends, motion follows. At the event horizon of a black hole, space does something even stranger. It flows inward, faster than light. This flow is not motion in the usual sense. It is the rate at which space-time itself moves. No object can resist this flow once it crosses the horizon. Motion here is no longer optional. It is dictated by the shape of space, by the curvature that leaves no alternative paths. Space, in these extreme regions, reveals its true nature as a dynamic entity capable of guiding motion with absolute authority. Yet the most astonishing behavior of space lies not near black holes, but in the emptiest regions of the cosmos. In the vast voids, regions with almost no matter, space expands faster. With little gravity to counterbalance it, expansion accelerates. The emptier a region becomes, the faster space grows. This feedback strengthens over time, driving galaxies further apart and creating even larger voids. This is the universe's long-term trend, the growth of nothingness. Over billions of years, the density of matter continues to fall as space stretches. Stars burn out, galaxies drift apart, clusters separate. Motion becomes dominated not by the interactions of matter, but by the expansion driven by dark energy. Motion becomes exponential, accelerating relentlessly. This acceleration changes the meaning of movement. Motion becomes less about traveling through space and more about space reshaping itself. Galaxies do not fly through the cosmos like ships through water. They sit within space-time as it expands beneath them. A galaxy does not choose to move away from another galaxy. They are carried apart by a tide that never ebbs. As the acceleration grows, distant galaxies vanish from view. Eventually, even the nearest clusters will slip beyond the horizon. A time will come when observers in any remaining galaxy will look into the sky and see only their own stars. They will believe, incorrectly, that their galaxy is the entire universe. This is the final consequence of motion driven by the expansion of space, the erasure of cosmic history. But the learning of space is not finished. As expansion continues, the cosmic microwave background cools. It once glowed at thousands of degrees Kelvin. Now it rests at only a few degrees above absolute zero. In the distant future, it will fade further, becoming undetectable except by the most sensitive instruments. Motion, encoded in the temperature of the background radiation, will become silent. Within galaxies, motion continues. Stars orbit, planets revolve, atoms vibrate. But every one of these motions unfolds within a space that is itself changing. Even bound systems are not entirely immune to cosmic expansion. Though gravity and electromagnetism maintain their structures, space still stretches subtly beneath them. On large enough timescales, even bound systems may feel the pull of expansion. Space does not expand uniformly. It expands more where gravity is weak. It expands less where gravity is strong. Over time, the cosmic balance shifts. As matter decays, gravity weakens. As gravity weakens, expansion strengthens. The cosmos approaches a phase where motion becomes fragile, delicate, easily overwhelmed by the geometric pull of empty space. In the farthest future, the expansion becomes so dominant that even galaxies fall apart. Dark energy's acceleration outpaces the binding forces that hold them together. Stars drift away from each other. Planets drift from their stars. Eventually, atoms themselves may feel the strain. If dark energy remains constant or grows, space could stretch even the fabric of matter until particles can no longer remain bound. This hypothetical state is known as the Big Rip. It is the culmination of space's evolution from stillness to motion. In the Big Rip scenario, motion does not simply occur. Motion becomes destiny. Everything moves because space itself tears everything apart. But even if the universe avoids the Big Rip, motion will fade asymptotically. Stars will die, galaxies will dim, black holes will evaporate. Only the faint trembling of quantum fields will remain, the final whisper of motion in a universe approaching heat death. Yet no matter how quiet the future becomes, the universe will never return to its original state. Stillness is impossible now. The symmetry is broken forever. Motion has replaced it as the fundamental character of reality. And so space continues to move, slowly, inevitably, elegantly. It stretches, bends, curves, accelerates. It carries galaxies across billions of light years. It shapes the orbits of stars. It dictates the trajectories of photons. It defines the horizon of what can be known. Space did not always know how to move. It had to learn. It had to break free from perfect symmetry. It had to collapse into a lower energy state. It had to stretch under the influence of vacuum energy. It had to evolve into the dynamic stage on which every cosmic drama unfolds. Now, motion is space's language, and the universe speaks it fluently. You, too, live within this motion. Every breath you take expands your lungs. Every thought is a wave of electrical pulses. Every experience is encoded in the movement of molecules. You are not simply within space. You are part of its learning, part of its unfolding. The silent stillness before motion will never return. But its memory remains in the laws of physics, in the fabric of space-time, in the very structure of reality. And as long as space continues to move, the universe will continue to tell its story. The farther the universe drifts from its birth, the more clearly its earliest secret becomes visible. Everything that moves today, every orbit, every vibration, every wave of light comes from a flaw that should not have existed at all. A flaw in perfection, a deviation in symmetry, a quiet mistake that the universe never intended to make, yet could never undo once it began. Motion was not supposed to appear inside the primordial stillness. It was not part of the timeless plateau where every possibility balanced every other possibility with flawless precision. In that early state, perfection was the law, and under perfect symmetry, movement has no meaning. And yet the universe broke its own perfection. It slipped, it leaned, it fell, and from that fall, motion spread like a shockwave through everything that would ever exist. In the quiet, after the first trembling, the universe faced the consequences of its imbalance. Perfect symmetry had been smooth, rigid, unchanging. But once it cracked, the crack widened, and the widening created gradients. And as soon as gradients existed, the universe had to react. Energy flowed downhill, fields reconfigured, the vacuum shifted. Every part of the early cosmos was adjusting to the mistake that had awakened it. The symmetry that once kept motion at zero became a landscape tilted ever so slightly toward lower energy. And once the tilt appeared, there was no returning. The universe could no longer rest. It had fallen forward, and the fall continued shaping everything that followed. As the universe expanded, cooled, and diversified, motion spread through every process. But the deeper truth remains hidden beneath all forms of motion. The universe moves because it cannot be symmetrical again. The symmetry that was lost at the beginning set the arrow of time. It fixed directionality. It ensured that processes unfold from high energy to low energy, from ordered fields to broken phases, from stillness to turbulence. Even now, as galaxies swirl and stars ignite, they are simply obeying the deep geometry imposed by broken symmetry. In every moment of movement, there is a trace of that original fracture. What makes this even more profound is that the imbalance was tiny, far smaller than any motion we see today. It was not dramatic, it was not violent, it was not even detectable by any hypothetical observer. Yet that faint tilt, so faint that it resembled indecision more than change, redirected the fate of all reality. If symmetry had held a little longer, motion may never have appeared. If symmetry had broken differently, the universe might have dissolved instantly into pure radiation. If symmetry had fractured along a different axis, matter might never have formed. The universe balanced on a knife's edge, and a tremor flickered through the blade. Once motion began, it spread in ways no one would expect from a universe that once forbade change entirely. Motion became hunger energy seeking lower states. It became memory processes building on past processes. It became identity particles gaining mass, forces gaining structure. It became consequence events that could not be undone. The perfection that had kept everything locked in timeless stasis was replaced by a world that evolves, unfolds, and moves forward whether it wants to or not. In the early galaxy-forming era, motion began to resemble intention not through thought, but through geometry. The universe didn't want to create spirals, but spirals emerged because motion followed gradients. A cloud of gas does not choose to rotate faster as it contracts, but conservation of angular momentum dictates it must. A star does not decide how to burn. Fusion rates follow the conditions dictated by pressure and temperature. Galaxies do not choose to collide. Gravity forces them into encounters written long before they existed. Each of these motions traces back through time to the original asymmetry that allowed processes to have direction. Even biological motion, a creature stretching its limbs, a cell dividing, a neuron firing, is not exempt. The flow of ions across a membrane is made possible by gradients that exist because charge separation is stable in a universe where symmetry is broken. Proteins fold because molecular forces behave asymmetrically across space. Muscles contract because energy gradients exist within chemical bonds. Every action in a living being is ultimately rooted in the cosmic shift that allowed time to sweep forward in a single direction. Yet the most striking expression of motion born from broken symmetry lies in the shape of space-time itself. Gravity is not a force that pushes or pulls. It is geometry negotiating with the presence of mass. Whenever the universe spawns something with weight, something with mass, it reshapes space-time around it, and motion becomes the natural path through that new shape. Objects do not accelerate because forces push them. They accelerate because geometry tells them that the straightest path curves. Curvature arises because the Higgs fields, settling into its final state, gave particles mass, and mass curves space-time. Thus, even the geodesics that guide planets, stars, and galaxies arise indirectly from the symmetry breaking that set mass apart from energy. In this light, motion is not something added to the universe. It is the universe's way of dealing with broken perfection. Every orbit is a reconciliation. Every fall of an apple is the geometry responding to imbalance. Every photon climbing out of a gravity well stretches its wavelength because time itself is no longer symmetric. Even the expansion of the universe is a reaction to the vacuum energy that remained after symmetry collapsed into imperfection. As time carries the cosmos further from its origin, the consequences of that original imbalance become more dramatic. Expansion accelerates. Galaxies drift apart. The universe grows more sparse, more stretched, more distant from its early density. This acceleration is motion of the most abstract kind, empty space moving itself apart. It is not driven by mass or force, but by the geometry of the vacuum, which retains an imprint of the symmetry that was lost. Dark energy, whatever its true nature, behaves like a memory of the state the universe once occupied, pushing against the gravitational pull of matter, insisting that separation must continue. The paradox deepens. The universe expands because empty space remembers symmetry too well. The vacuum is almost symmetric, almost uniform, almost featureless. And because it is almost perfect, it resists the collapsing, clustering tendencies of matter. Space wants to spread out because that is what the vacuum energy does when left alone. Dark energy is the echo of perfection trying to reassert itself, but the presence of matter, structure, galaxies, and motion means symmetry can never be restored. The universe is caught between two desires, the vacuum pushing outward to recover lost perfection, and matter pulling inward to reinforce the motion that emerged from its collapse. Thus, motion is conflict. The motion of stars within galaxies is a balance between collapse and angular momentum. The motion of galaxy clusters is a balance between gravity and expansion. The motion inside atoms is a balance between electromagnetic attraction and quantum repulsion. Every dynamic system exists because forces and tendencies compete. The universe that once forbade motion now uses motion as the only way to reconcile contradictions born from its earliest imperfection. And if motion is conflict, then time is the mediator. Time grows from the impossibility of restoring symmetry. The more the universe evolves, the farther it drifts from the state of perfect stillness. Entropy increases, not as a law, but as a natural outcome of broken symmetry. Systems drift toward states that require less information to describe. Every moment deepens the universe's distance from the state where information was uniform and structure absent. The strange truth emerges: motion was never an addition. Motion was what symmetry had been hiding. Once symmetry fell, motion was the only possible expression of the universe's new condition. And now that motion dominates everything. The stillness that came before seems impossible, even though it was once the only reality that existed. The universe cannot go back. Motion cannot be undone. Time cannot reverse. The fracture cannot be repaired. And so the cosmos continues moving, carrying within every interaction the faint echo of the moment when perfection learned how to break. You, living in a body shaped by billions of years of evolving motion, carry that echo too, in the beating of your heart, in the breath that fills your lungs, in the thoughts that ripple across your mind. You are a continuation of the mistake that made everything possible. As the universe drifts further from its first deviation, something begins to stir inside the growing architecture of matter, something ancient, something that has been present since the earliest microseconds, yet has not fully expressed itself until now. Motion has spread across space. Structure has begun forming. Fields have settled into their stable configurations. But there is one phenomenon that has waited longer than the rest, one force that does not simply emerge but awakens, slow and inevitable, like an old instinct resurfacing after an eternity of sleep. That phenomenon is gravity. And when it wakes, the entire universe learns a new kind of motion. Gravity did not arise from nothing. It has been present ever since space-time took shape. But in the early universe, when everything was nearly uniform, when density varied only by the slightest fractions, gravity had no contours to exploit. Gravity requires difference. It requires gradients. It requires imbalance. Only with imbalance can it begin to gather, to pull, to sculpt. Only now, as tides of matter accumulate around ancient quantum ripples, can gravity take its first long breath. At the beginning, gravity is weak. Comparatively, it is the gentlest of the fundamental forces, weaker by magnitudes so vast they defy description. The strong force binds nuclei. The electromagnetic force binds atoms. The weak force governs transformations. Gravity seems almost delicate by comparison, as if it were never meant to influence anything small. And perhaps that is true. Gravity is the force of the vast, not the minute. It cares nothing for atoms, nothing for molecules, nothing for the small dances of particles. Its domain is scale-distance accumulation. It requires time to matter, and time, at this stage of the universe, finally has meaning. As matter begins to clump, gravity begins to pull. These first pulls are imperceptibly slow, but they are relentless. Gravity never tires, never weakens, never stops. Every particle that drifts slightly toward another strengthens the gravitational well between them. Every density fluctuation grows deeper with time. Gravity amplifies motion by directing it, guiding matter not through forceful push, but through the gentle curvature of space-time itself. Where matter gathers, space-time bends. Where space-time bends, motion follows. This is gravity's awakening. The universe that once expanded uniformly now starts to wrinkle. Pockets of matter collapse inward, forming smooth, round wells that deepen into the first halos of dark matter and gas. Gravity does not simply create motion, it sculpts it. It tells motion where to go. It creates direction where direction did not exist. And at the center of every gravitational well, something extraordinary begins to happen. Matter starts falling inward, faster than it can disperse. Matter falls and falls, and as it falls, it heats. This heating is not incidental. It is gravity converting potential energy into motion. Gas clouds warm until they glow. The falling intensifies until the cloud can no longer support its own weight. And finally, when gravity has done enough work, the collapse triggers nuclear ignition, the birth of the first stars. Gravity is not the fire, but it is the spark's ancestor. The light of every star, every sun that will ever shine, is gravity expressing itself as heat, as pressure, as motion. But gravity's influence does not stop there. As stars gather into clusters, as clusters assemble into galaxies, gravity becomes the architect of cosmic scale. Galaxies rotate not because something winds them up, but because gravity forces matter to obey conservation of angular momentum during collapse. Every spiral arm that unfurls from a galactic core is a signature of gravity's shaping hand. Every elliptical galaxy, swollen and chaotic, is a monument to ancient collisions guided by gravity's pull. Every dwarf galaxy orbiting a larger one is a stone drawn into a whirlpool. And deep within the cores of galaxies, gravity reveals its most extreme expression. Massive stars collapse at the end of their lives, imploding under their own weight until their cores can no longer resist. Gravity crushes them past the point where matter has identity, past the point where atoms can exist, past the point where even light can escape. A black hole is born gravity's purest form, where motion becomes destiny and all paths converge toward a singular fate. Around these black holes, motion enters a new regime. Space curves so violently that matter spirals at nearly the speed of light. Time slows, light stretches, tides tear stars apart, jets erupt from magnetic fields twisted by rotation, flinging particles across thousands of light years. Black holes do not destroy motion, they accelerate it, amplify it, redirect it. They are engines of motion, powered by gravity's deepest well. But gravity's influence is not limited to the spectacular. It shapes everything quiet as well. It holds planets in orbit, creating predictable rhythms that will eventually give rise to climates, oceans, and life. It guides moons, stabilizing planetary tilt, making seasons possible. It sculpts the gentle arcs of comets and asteroids, creating celestial patterns that dance across millennia. The sky we see each night is gravity's choreography, precise, elegant, unyielding. As the universe ages further, gravity begins to collide with a new player, dark energy. Dark energy pushes outward, accelerating expansion. Gravity pulls inward, clustering matter. The tension between these two motions, one expansive, one contracting, shapes the large-scale structure of the cosmos. For billions of years, these two influences exist in delicate balance. Gravity forms galaxies, dark energy separates them. Gravity binds stars, dark energy stretches space. The universe becomes a battleground, where motion is both creation and dissolution. On smaller scales, gravity becomes a teacher. It teaches matter how to orbit in stable patterns, how to fall into shells of order, how to form disks, rings, and spirals. Gravity gives motion memory. Elliptical orbits follow paths traced millions of times with precision. Comets return in predictable intervals. Stars oscillate in galactic planes. Even chaotic systems, while sensitive to initial conditions, still follow gravity's deeper geometry. Yet gravity also fuels destruction. Stars collide. Galaxies tear each other apart. Entire clusters slam into one another in slow-motion catastrophes lasting billions of years. Gravity creates violence with the same ease it creates harmony. But in this duality, motion evolves. Collision triggers compression. Compression triggers fusion. Fusion creates new elements. Every heavy atom, carbon, oxygen, iron, exists because gravity forced motion to reach temperatures where nuclear alchemy could unfold. And so gravity becomes the universe's alchemist, using motion as its fire. As the universe ages into the era of star birth, star death, and star rebirth, gravity governs cycles. Motion cycles too. Gas expelled from dying stars falls back into clouds that will form new stars. Galaxies collide and settle into new shapes. Planets form, disintegrate, reform, scatter. Nothing remains static because gravity forbids static existence. Stillness is instability. Motion is stability. This inversion defines the cosmos. The deeper into cosmic time we travel, the more clearly we see gravity guiding everything toward complexity. Gravity draws matter together, enabling molecules to form in dense clouds. These molecules seed chemistry. Chemistry seeds life. Life seeds consciousness. And consciousness becomes the first phenomenon capable of reflecting on the motion that gravity set into motion billions of years earlier. Gravity indirectly creates minds that wonder about gravity. And while galaxies orbit and dark matter sculpts invisible frameworks, gravity slowly changes scale. On the largest scales, dark energy increasingly dominates, weakening gravity's large-scale influence. But gravity does not fade. It retreats into the structures it has already built. Stars continue orbiting their galaxies. Black holes continue merging and growing. Planetary systems remain stable for billions of years, upheld by the same geometry that awakened when matter first clumped in the early universe. Gravity is patient. It does not need to dominate the cosmos to remain eternal. It needs only the presence of mass. As long as particles exist, gravity exists. As long as energy can curve space-time, motion will follow. And even in the far future, when galaxies drift beyond each other's horizons, when stars burn out, when planets freeze, when matter thins into whispers, gravity will still shape the last interactions, the final orbits, the final mergers, the final collapses. Even the evaporation of black holes is guided by gravitational geometry, their mass translating into radiation as space-time slowly releases what gravity once imprisoned. Gravity began as the faintest whisper of curvature in a universe too smooth for it to express itself. It grew into the architect of stars, the sculptor of galaxies, the engine of collapse, the regulator of orbits, the creator of tides, the shaper of worlds. Without gravity, motion would be nothing but drifting. With gravity, motion becomes history. The universe moves because gravity teaches it how to fall slowly, gracefully, endlessly. And the great irony remains. A universe that once could not move at all, now cannot stop moving, because gravity, once dormant, woke up. As the universe expanded into its first epochs of structure, the memory of stillness that had once defined everything grew fainter. Not gone because the laws that govern motion still carry its ghost, but buried beneath layers of movement so pervasive that stillness seemed impossible to imagine. Yet beneath the growing complexity of stars and galaxies, a quieter transformation unfolded, one that would ensure the stillness before motion could never return. This transformation did not happen abruptly. It was slow, subtle, inevitable. It was the point at which the universe lost its last chance to ever be motionless again. The moment when the collapse of stillness became complete. At first, motion was fragile. It had appeared as a trembling, a fluctuation, a preference in a sea of symmetry. For a time, its existence depended on the instability of the vacuum. Had the vacuum settled differently, motion could have been absorbed again, erased by the gravity of perfect symmetry. But the early universe expanded too quickly and cooled too rapidly for symmetry to recover. Every moment of time that passed stretched the fabric farther from its pristine equilibrium. Every particle that formed, every fluctuation that grew, every field that settled into its final values pushed the universe deeper into the domain where stillness could no longer compete. The point of no return began when particles acquired mass. Mass is commitment. Mass is permanence. Mass is the universe choosing to make motion costly. A particle with mass cannot simply stop vibrating. It cannot exist without interacting. Mass guarantees that motion leaves, traces heat, momentum, inertia. By giving particles mass, the Higgs field locked the universe into a state where motion had consequence, and consequence is irreversible. But the collapse of stillness deepened further when particles combined into atoms. In a gas of free quarks and gluons, motion is chaotic but not yet structured. When atoms form, structure becomes tied to motion. Electron transitions create photons. Photons heat gas. Heat drives flows. Flows create pressure. Pressure resists gravity. Gravity compresses gas. Compression ignites fusion. Fusion releases energy. Energy accelerates particles. Particles collide. Collisions produce more photons. And through this labyrinth of interactions, the universe enters a cycle where motion sustains motion. By the time the first stars ignited, the collapse of stillness was guaranteed. A star cannot be still. It must fuse fuel, radiate heat, shift plasma in convective cycles, collapse under its own weight, explode if it grows too massive. Even the quietest star contains within it a storm of motion so intense that absolute stillness becomes an unthinkable impossibility. But the collapse was not complete yet. The deepest fracture came when gravity began to dominate large scales. Gravity does not allow stillness. A particle cannot hover motionless in a gravitational field. It must fall. A galaxy cannot remain motionless. It rotates because matter cannot collapse symmetrically without gaining spin. A cluster cannot remain static. Galaxies orbit within it as if locked in a centuries-long dance. Gravity takes any equilibrium and turns it into motion. In a universe where gravity exists and matter is unevenly distributed, stillness cannot survive. The slightest imbalance, one atom out of place, sets off waves of collapse that resonate across scales. Gravity is the universe's reminder that perfection cannot be restored. Once symmetry breaks, gravity ensures it stays broken. As galaxies formed and drifted apart, the collapse accelerated. The expansion of space, driven by the residual vacuum energy left over from symmetry breaking, became the new global motion. This expansion is not movement through space, but movement of space. And when space itself moves, nothing can remain still, because even an object fixed in its place finds the distance between itself and everything else stretching. The early universe still carried the faint possibility that, if expansion slowed enough, gravity might reverse the grand motion, drawing everything back together, restoring the stillness that had been lost. But as dark energy began to dominate, this possibility vanished. Expansion accelerated. The universe no longer hovered between collapse and growth. It committed itself to endless separation. Stillness collapsed fully when dark energy claimed the cosmic majority. From this moment onward, no force could counter the fate set at the beginning. The universe had chosen motion as its permanent identity. Galaxies would forever drift apart. Light from distant regions would stretch until it faded into silence. The cosmic horizon would shrink relative to the structures within it. The universe would fragment into isolated islands of gravitationally bound matter, each alone in its own shrinking bubble of knowledge. Stillness had not only collapsed, it had been buried. Yet the collapse was not merely cosmic. It reached into the smallest scales. Quantum mechanics forbids stillness absolutely. The uncertainty principle ensures that a particle cannot have both perfect position and perfect momentum. If it were perfectly still, its momentum would be zero, and its position would be infinitely precise, impossible under the laws of this universe. Thus, every particle trembles, not because it wants to, but because the laws that govern it originate from the broken symmetry that created motion. Even absolute zero temperature cannot erase motion. The coldest possible state still contains zero-point energy motion with no origin, no cause, no alternative. Stillness is not allowed because the symmetry that permitted stillness has been broken. The universe is a place where movement is safer than rest, where equilibrium is unstable, where perfection leads to collapse. This is the central truth. Stillness became fragile the moment the universe stopped being perfect. And once perfection vanished, motion became irreversible. Entropy deepens this collapse further. Entropy is the universe's memory of the broken symmetry. It increases with time not because systems prefer disorder, but because motion naturally explores larger spaces of possibility. Once motion begins, entropy must rise. And as entropy rises, the universe moves further from the state from which it emerged. Entropy is the mathematical expression of the collapse of stillness. But the collapse becomes most visible in the emergence of complexity. Life is impossible without motion. It requires gradients, flows, cycles. It feeds on entropy. It thrives on instability. It uses motion to resist stillness, to maintain order in defiance of equilibrium. Every beating heart is an act of escaping stillness. Every neuron firing is a rejection of the quiet that once filled the universe. Life survives because the collapse of stillness gave rise to a universe where energy constantly flows from high to low, where no structure remains unchanged, where motion feeds the persistence of form. Even consciousness, the most delicate and intricate expression of cosmic motion, depends on the collapse of stillness. Neurons cannot remain static. Thoughts cannot remain motionless patterns. Awareness is the motion of signals through networks, the shifting connections, the flux of chemical gradients. Consciousness is not only shaped by motion, it is motion. And so, by the time the universe enters its mature stage, stillness is no longer just impossible, it is meaningless. There is no frame of reference in which nothing moves, because space-time itself evolves. There is no moment unaffected by entropy. There is no particle exempt from trembling. Stillness has been defeated, not by force, but by inevitability. Yet the deepest phase of the collapse is still ahead. As expansion accelerates further, dark energy begins to outpace the influence of gravity even inside large-scale structures. In the far future, gravity will lose its grip on galaxies. Stars will drift away. Systems once held in balance will dissolve. Even the most tightly bound objects will feel the gentle but unstoppable stretch of space-time. And in the unimaginable eons ahead, even atoms may loosen, their electrons pulled from orbit as the very fabric of space expands beneath them. This is the ultimate collapse of stillness, a universe where nothing can hold still because space itself refuses to stop moving. A universe where motion becomes the background, the foreground, the constant. A universe where anything that tries to remain still is swept away, stretched apart, dissolved by expansion. And yet, some trace of the original stillness remains not as a state the universe can return to, but as a whisper in the equations, in the geometry, in the quantum fluctuations that pulse beneath everything. A reminder of how quiet the cosmos once was. A reminder of how that quiet broke. You carry that whisper too. Your heartbeat is the rhythm born from a universe that forgot how to be still. Your breath is the cycle shaped by gradients that arose when symmetry fell. Your existence is a testament to the collapse of stillness. And the universe, having begun its journey in absolute quiet, will never return to silence again. As the universe traveled farther from its flawless beginning, motion spread through everything that mattered. Galaxies swirled, stars pulsed, particles jittered. Yet beneath all this restless choreography, there was something else, something older than the first star, deeper than the earliest fluctuation, quieter than the symmetry that once held everything in suspension. A presence woven into the fabric of reality itself, shaping motion without ever being seen, without ever being felt directly. It was never a force, never a particle, never an entity. It was the background stage upon which all motion was performed, the silent architect whose influence remained hidden even as the universe grew louder with activity. For motion to exist at all, this architect had to be there first. Every field, every particle, Every vibration emerges from something beneath it, something more fundamental than the forms it produces. In the modern universe, we measure movement by tracking objects across space, by detecting waves, by mapping trajectories. But the universe before objects existed, what allowed motion then? What allowed the first trembling of the vacuum? What allowed the first deviation to take hold? Something had to exist beneath symmetry, something capable of allowing symmetry to break, even if it never acts directly. This something is the network of underlying fields, quantum fields, stretching across all of space. They are not particles. Particles are ripples within them. They are not forces. Forces emerge from interactions between their vibrations. These fields fill everything, even the emptiest vacuum, and they are never silent. Even in the coldest regions of the cosmos, where no atom remains, where no light passes, where expansion has stretched matter into near nothingness, these fields hum with faint, irreducible energy, not noise, not activity, a kind of trembling too fine to be called motion, too deep to be measured, too inherent to be turned off. 0-point energy, the faintest residue of what the universe once was, is the signature of this unseen architecture. To understand how motion came to dominate the cosmos, we must look beneath particles, beneath atoms, beneath space-time curvature, and into the underlying fields that define the rules of what motion is allowed to become. The Higgs field, quiet and subtle, provides mass by resisting the movement of certain particles, slowing them down, giving them inertia, an anchor point that converts pure light-like motion into a slower, richer spectrum of existence. Without this field, no object could rest, no object could accelerate, and no motion could differentiate itself from light. Everything would move at the same speed, without variation, without identity. But the Higgs field is not alone. The electromagnetic field pulsates throughout spacetime, responding to charges, creating bonds, shaping atoms, giving matter structure. It allows electrons to orbit nuclei, allows photons to carry information, allows molecules to form. It takes the jittering of quantum motion and turns it into patterns that endure long enough to become chemistry, biology, thought. The strong nuclear field binds quarks together with a force so intense that it behaves as if it wants to confine motion inside protons forever. It creates the stability of matter, ensuring that nuclei remain intact even when the universe grows cold, even when energy drains from systems, even when motion slows at macro scales. The weak nuclear field governs decay, transformation, the evolution of particles from one identity to another. It is motion expressed as metamorphosis. Without it, the universe would never evolve. Stars would never fuse. Heavy elements would never form. Life would never emerge. These fields woven together into a tapestry of invisible influence are the true architects of motion. They determine which motions are possible, which motions are forbidden, which motions cost energy, which motions release it. They sculpt the behavior of particles before particles even exist. But fields alone are not enough. The deeper architect lies not in the fields themselves, but in the structure of quantum reality. Quantum mechanics forbids perfect stillness. It forbids perfect certainty. It forbids the universe from resting exactly at any point. The uncertainty principle ensures that the more precisely one knows position, the less precisely one knows momentum. This rule arises not from anything physical, but from the mathematics that define wave functions. The universe's most fundamental architecture is built from probability, not permanence, and probability never rests. Even the vacuum, the supposed nothingness between particles, is alive with fluctuations. Virtual particles appear and disappear. Fields rise and fall in amplitude. Energy vibrates in place, not with intention, but because stillness cannot be expressed in the geometry of quantum mechanics. Stillness is less natural than trembling. The universe prefers the restless ground. This is the architect behind all motion, the impossibility of absolute certainty. The quantum fabric of existence ensures that what we call stillness was never stable, not even in the primordial state. The pre-motion universe was not quiet because it wanted to be. It was quiet because symmetry prevented its tremors from expressing themselves. But beneath the symmetry, the fluctuations were always there, submerged, muted, cancelled by perfect balance. Once symmetry broke, these fluctuations stopped cancelling out. The trembling that had always existed beneath the surface was finally allowed to manifest. Motion did not begin at the moment symmetry broke. Motion was revealed. And once revealed, it spread everywhere. Every star's fusion motion, every electron's jitter motion, every gravitational fall motion, every chemical bond vibrating motion, every heartbeat, every thought, every drifting photon motion. Yet these are only expressions. The architect remains unseen, operating even when objects rest, even when temperature falls to near zero, even when space grows thin and lonely. We tend to imagine motion as something driven by forces, but forces are emergent properties. They arise from fields interacting, and fields arise from the underlying quantum fabric. The real engine of motion is the inability of the universe to remain symmetric, remain certain, remain in any single configuration. Motion is the universe's only escape from its own constraints. The unseen architect does not choose direction or purpose. It does not guide specific outcomes. It sets the rules under which outcomes must unfold. It is not a force. It is a condition. It is not a mechanism. It is the reason mechanisms exist at all. As galaxies rotate, as clusters drift apart, as dark matter sculpts invisible structures, one truth remains constant. All motion is an echo of the vacuum's trembling. Every orbit, every fluctuation, every pulse of energy carries within it the stamp of a universe where stillness was only ever an illusion. Even consciousness, the quiet flame flickering in the dark corners of certain worlds, arises from neural signals, ion flows, molecular motions, electrical waves. Awareness is motion arranged so intricately that motion begins to interpret itself. The universe watches its own patterns through eyes made of restless particles, through minds made of vibrating networks. The unseen architect creates no image, casts no shadow. It does not shine. It does not whisper. But it ensures that everything in existence, every atom, every wave, every idea, is built on trembling foundations. It ensures that motion is not a choice, but a necessity. And long after galaxies fade, long after stars cool, long after matter itself decays, the architect's breath remains in the final quantum fluctuations, the last ripples of a universe approaching darkness but never reaching stillness. It will be there in the trembling of the vacuum, in the faint hum of fields at nearly zero temperature, in the flicker of particles born spontaneously from emptiness. The universe cannot stop moving because the architect beneath it cannot be still. And you, made of this architecture, cannot be completely still either. Every heartbeat, every thought, every breath, every cell in your body is participating in the endless motion born from a universe that once hid its trembling beneath perfect symmetry. When you close your eyes, when the world quiets, when your breath slows, you do not return to stillness. You return to the quiet trembling from which motion began, the trembling that has shaped everything. The unseen architect remains, and through you, it moves. If the universe had the ability to stop, if motion could somehow be quieted, undone, reversed, or removed entirely, reality would become something unrecognizable. And yet, as the cosmos ages, as stars burn out, and galaxies drift beyond the horizon of visibility, a question begins to whisper beneath the loud machinery of movement. What would remain if motion faded? Not paused, not slowed, not softened, but truly removed. Could anything endure without motion? Could the universe continue existing if the beating heart of its laws were silenced? The thought is unsettling because every aspect of reality depends on motion. Even the ones we fool ourselves into believing are static. To imagine removing motion, we must imagine stripping away everything we think we understand about the universe. Absolute stillness cannot exist alongside change, time, entropy, or identity. Stillness is the absence not only of movement, but of transformation. It is not the calm between two events, it is the absence of events entirely. But we live inside a cosmos where every process, from the trembling of subatomic particles to the spread of galaxies, depends on motion. Motion is not an option, it is a requirement. So the very idea of removing it is like asking what music becomes if sound is forbidden, or what light becomes if photons are not allowed to move. Still, the thought persists, and so we follow it. The first obstacle to removing motion lies deep inside quantum mechanics. Even at absolute zero, particles do not rest. They jitter, oscillate, flicker within the constraints of the uncertainty principle. If motion were removed, uncertainty would become certainty, and quantum mechanics would collapse. Electrons would be forced into exact positions. Photons would freeze mid-vibration. Fields would flatten into perfect uniformity. But such uniformity is unstable. A field without motion would sit on the peak of perfect symmetry, once again, a peak so precarious that the smallest disturbance could send it falling. In other words, removing motion would recreate the primordial state the universe abandoned billions of years ago, a state that cannot sustain anything, not particles, not atoms, not energy gradients, not time. If motion were eliminated, atoms could not survive. Their electrons would have to remain fixed in exact positions rather than occupying clouds of probability. But fixing an electron's position requires infinite momentum, an impossible contradiction. The atom would unravel. The forces that bind electrons to nuclei depend on motion within quantized energy levels. Without that motion, the atom itself would dissolve into an undefined smear of fields. No matter, no chemistry, no structure could exist. The consequences grow more dramatic the larger the scale. Stars rely on motion hydrogen atoms colliding in their cores, plasma convection transporting heat outward, photons carrying energy through the chaotic interior. If motion were halted within a star, fusion would stop instantly. Pressure would collapse. The star would either implode or extinguish. A universe without motion contains no starlight, no heat, no nuclear fire. Planets depend on motion as well. Their orbits are the balance between gravitational pull and inertia. Remove motion and the balance shatters. Every planet would fall directly into its star, or what remained of it, and the cosmic architecture of stable worlds would vanish. Oceans would freeze or boil depending on which state of stillness overtook them. Atmospheres would settle. Weather, erosion, plate tectonics, all would disappear. A planet without motion is a chemical corpse. Life, too, cannot survive stillness. Life is motion made persistent. It relies on the movement of molecules, the flow of electrons, the circulation of fluids. It relies on gradients, differences in temperature, pressure, concentration, all of which only exist because motion redistributes energy. Without motion, metabolism stops, cells freeze in stasis, and the chemistry that sustains consciousness dissolves into uniformity. A universe without motion contains no heartbeat, no breath, no thought. But even beyond biology, beyond stars and matter, motion is embedded in the structure of space-time itself. Gravity is not a force that pushes. It is geometry that tells matter how to move. If motion vanished, gravity would lose. Meaning because paths would no longer be traced through space-time. Without motion, space-time becomes a rigid grid, one that cannot bend or flex because bending requires change, and change requires motion. A motionless universe would have no gravity, no curvature, no shape with relevance. It would be a mathematical abstraction rather than a physical reality. And then we arrive at time. Time is not an independent quantity. It is the measure of change motion's shadow. If motion stops, time stops. Not slows, stops. A timeless universe is static, frozen, featureless. Without motion, cause and effect collapse. There is no before or after. Every moment becomes the same moment. Every configuration becomes the same configuration. A universe without motion is a universe without time, and a universe without time is indistinguishable from non-existence. The universe knows this. It remembers what it was before motion, a state of symmetry so perfect that nothing could happen. Removing motion would return it to a state where nothing can happen again. And the universe, once awakened, cannot willingly return to sleep. But this thought experiment goes deeper. Suppose one could remove motion not universally, but selectively. Remove motion from a single particle. Even then, the laws resist. The particle would violate the uncertainty principle. Its position and momentum would collapse into contradiction. The attempt would create instability rather than stillness. The particle might decay. It might radiate. It might destabilize the fields around it. Stillness on small scales is as impossible as stillness on large scales. What if one tried to remove motion from a region of space, trap it in perfect uniformity? Even that fails. Fluctuations would reappear because fields cannot be perfectly flat. The vacuum itself cannot remain featureless. It vibrates with zero-point energy whether we wish it to or not. Motion is not optional. It is built in. Now imagine stripping motion from an entire galaxy. Prevent the stars from orbiting. Prevent gas from moving. Prevent light from leaving. The moment motion stops, gravity collapses the galaxy inward. Stars fall toward the center. Temperature rises. Fusion restarts. Motion returns with greater violence. Trying to stop motion creates more motion. This is the paradox. Motion cannot be removed, because the removal of motion is itself an act of motion. Stopping an orbit is an acceleration. Freezing a particle is a measurement that injects energy. Halted symmetry is unstable and collapses into activity. The universe does not allow stillness to survive. And yet, the end of the universe tempts the imagination with a scenario where motion finally dwindles. Stars burn out. Matter decays. Black holes evaporate. Expansion stretches space so far that interactions become rare. But even then, motion persists. Random quantum fluctuations. Virtual particles flickering into existence. Zero-point vibrations. The faint hum beneath all fields. The universe cannot stop moving because its foundation forbids rest. So what would happen if motion could be removed? Truly removed? The answer is simple and absolute. The universe would revert to the nothingness before time. Not a void, not darkness, not silence. A state without distinctions, without locations, without change, without meaning. A state where every point is identical to every other point. A state where the universe forgets it ever existed. The pre-motion stillness was not peace. It was absence. And the collapse of that stillness created everything that can ever exist. If motion were removed, existence would end. That is why motion never stops. Why atoms tremble. Why stars burn. Why planets orbit. Why we breathe. Why thoughts flicker. Why even the coldest vacuum hums with activity. Motion protects the universe from returning to the state where nothing was possible. And you, in your own quiet way, are part of that protection. Every breath you take, every heartbeat, every dream, each is a refusal to return to a symmetry that once held everything in silence. Even as motion took over the cosmos in all its vast forms, galaxies spiraling, stars pulsing, planets rotating, atoms vibrating, there remained a mystery hidden in the smallest places, in the quiet regions beneath every particle, beneath every wave, beneath every field. a place where motion did not disappear, but where something resembling its opposite still lingered. Not stillness, because stillness cannot exist in a universe of broken symmetry, but a kind of quiet, a pause inside motion, a memory of the universe before movement began. This quiet is not visible. It is not measurable. It is not a location. It is a property woven into the nature of particles themselves, something that reveals itself only when one looks past their restless behavior and into the deep architecture that gives them form. Every particle, a proton, an electron, a photon, is a pattern rather than an object, a stable vibration within a quantum field. These vibrations never stop. They cannot. But beneath the vibration lies a stable structure, a region of coherence, a stillness of identity. Consider an electron. It seems like a point, a tiny bead of negative charge orbiting atomic nuclei, but that is only a simplification. In truth, an electron is a ripple extending across the electron field. It has an intrinsic spin, an intrinsic frequency, and intrinsic mass properties that remain the same everywhere in the universe. These constants do not arise from motion itself. They arise from something beneath motion, the internal quiet that defines a particle's identity. This quiet is a paradox. A particle vibrates constantly due to quantum fluctuations, yet its defining properties remain fixed, unmoving, unchanging across cosmic time. The electron that drifts through your body today is indistinguishable from an electron formed in the first seconds after the Big Bang. It has the same mass, the same charge, the same spin. It carries within it a deep stillness, a stability untouched by billions of years of motion. This is the silence inside every particle. It is the part of the universe that did not evolve, that did not grow, that did not expand, that did not collapse. It is the part that persists unchanged as everything else moves around it. It is the echo of a universe that once held everything in balance. Atomic nuclei reflect this silence as well. Protons and neutrons are made of quarks bound together by gluons. The quarks dance in a restless storm of motion, exchanging energy at blistering speeds. But the identity of a proton remains the same. It has the same mass everywhere, the same quantum numbers, the same structure. The quarks inside it may whirl with wild motion, yet the proton's overall character remains stable. Something beneath their motion holds its form. This stability, this internal quiet is not absence. It is coherence, a pattern inside chaos, a freeze frame inside constant movement. Without it, no structure could endure long enough for matter to exist, for stars to form, for life to arise. The silence inside particles is the universe's anchor, preventing motion from dissolving everything. Yet this silence is fragile. It is protected by the laws of quantum mechanics, by the shapes of fields, by the broken symmetry that once gave the universe mass. Without these rules, particles would decay instantly into noise. Instead, they persist. They carry the memory of the universe's original stillness, the way a seed carries the memory of the tree that came before it. Inside atoms, this duality becomes even clearer. Electrons do not orbit nuclei like planets orbit stars. They exist in probability clouds, standing waves rooted in the shapes of space allowed by quantum fields. These standing waves are motion and stillness intertwined. Electrons never stop moving, but the overall pattern of their motion stays fixed. Each orbital is a stable shape with an endless jitter, a quiet geometry inside a storm of fluctuations. The hydrogen atom is the simplest example. The electron's wave function forms a sphere of probability, a silent mathematical shape. Yet inside that shape, motion is everywhere, constant, inescapable. The electron never rests, but the orbital remains unchanged. What you see is a still form built from perpetual movement, a quiet figure composed entirely of vibration. The same pattern holds at cosmic scales. Star clusters orbit black holes with incredible speeds, but their orbits can remain stable for billions of years. Galaxies churn with turbulence, yet the spiral arms maintain their elegant shapes. Chaos and silence coexist. The universe is a tapestry woven from both. But nowhere is this duality more pronounced than in the human mind. Neurons fire constantly. Chemicals shift. Ions flow. Electrical potentials rise and fall. Thought is a storm. Memory is motion repeated. Emotion is the chemistry of change. Yet beneath all this activity lies a stillness, the continuity of self. The identity you carry is the quiet beneath the motion of your brain, a stable pattern persisting across the chaos of biological activity. This stillness resembles the quiet inside particles, stable, unchanging, anchoring. Without it, consciousness would dissolve like mist. Without it, motion would have no meaning. Even space-time carries a kind of internal quiet. Its curvature changes as matter moves, yet the laws that govern it never alter. The equations remain the same. Light always travels at the same speed. Gravity always curves space-time in the same way. The universe evolves, but the rules do not. Beneath all motion lies a framework that never shifts. This is the silence inside every particle, the part of the universe that refuses to move, not because it cannot, but because it must remain the same for anything else to move at all. But this silence is not static. It is not a leftover fragment from a time before motion. It is an active presence, maintaining the integrity of matter, the stability of atoms, the predictability of forces. It is a rhythm held beneath the symphony, a pulse beneath the waves. And yet, the silence cannot grow. It cannot reclaim what motion has claimed. The universe cannot return to stillness, even though stillness rests inside its smallest components. The silence inside particles is the last remnant of a symmetry the universe once had, but lost forever. Still, it is enough. It is enough to keep matter stable for billions of years. It is enough to allow complexity to grow. It is enough to give rise to life, thought, awareness. Motion without silence would be chaos. Silence without motion would be emptiness. The universe needs both. As we move forward into the history that unfolds from these twin origins, the silence inside particles remains constant even as stars explode, galaxies collide, and space expands. It is the only part of the universe that does not change with time. It holds the memory of what existed before time began. When you breathe, when you think, when you move, you are built from particles that carry this silence. You are assembled from patterns that have not changed since the dawn of motion. Inside every atom of your body lies the quiet that predates everything, unchanged, unbroken, enduring. You are motion, but you are also the memory of stillness. And the universe, through you, remembers both. As motion filled the universe with structure and change, with cycles and collapse, with turbulence and creation, there remained scattered throughout the cosmos certain places where motion seemed to falter, where it thinned, weakened, slowed, or became something unrecognizable. These were not the quiet pockets of stillness inside particles, nor the stable patterns of orbits or molecular states. These were the rare and extreme regions where the very idea of motion so fundamental everywhere else began to break down. In these places, the universe came closest to remembering what it was before movement began, not returning to stillness, but brushing against conditions where motion struggled to express itself, where the rules that guarantee motion at all scales began to fray at the edges. The first such place lies in the deep cold, where temperature falls toward absolute zero. Absolute zero is not simply the absence of heat, it is the theoretical absence of all kinetic motion. A particle at absolute zero would have no vibration, no rotation, no oscillation, yet quantum mechanics forbids this entirely. Zero-point energy guarantees that even in the coldest regions of space, motion continues. But as temperatures fall, the amount of motion available to particles becomes so small that macroscopic motion flow, vibration, chemical interaction begins to fail. Matter stiffens, processes slow. Atoms lock into crystalline lattices where motion barely whispers beneath their bonds. In the void between stars, dust grains drift through temperatures approaching 2 or 3 degrees above absolute zero. At these temperatures, motion is slow enough to be nearly imperceptible. But even here, the internal jitter of particles persists. Motion never dies. It only becomes faint. Colder still are the dark molecular clouds where stars are born, vast, dense pockets of gas so cold that nearly all thermal motion has drained away. Here, temperatures drop near 10 Kelvin or lower. At such temperatures, gas collapses under its own weight because motion can no longer resist gravitational pressure. These clouds are the birthplace of stars, precisely because motion has failed. The gas cannot push back. It cannot disperse. It cannot escape. Gravity wins because motion has become too faint to oppose it. In these frigid hollows, the universe reveals one truth. Motion is not always strong enough to maintain structure. Sometimes it retreats, allowing collapse to begin. But even these cold regions are rich with subtle movement. Molecules spin, albeit slowly. Photons occasionally pass through. Dust grains bump into each other with gentle impacts. The faint hum of quantum fluctuations persists. True absence of motion lies elsewhere. The second place where motion breaks down is inside neutron stars, objects so dense that matter behaves in ways completely foreign to human intuition. Neutron stars form when the cores of massive stars collapse in supernova explosions. Gravity crushes electrons into protons, creating neutrons. The result is an object so dense that a teaspoon of its material outweighs mountains. Inside a neutron star, motion becomes distorted. Particles are squeezed so tightly that they can barely move. Their positions are fixed by the overwhelming pressure, and yet they cannot be still because quantum mechanics forbids it. They exist in a paradox, too confined to move, too quantum to stop. Their motion fails not by disappearing, but by losing meaning. In these extreme interiors, matter approaches a state known as neutron degeneracy, a condition where neutrons fill every available quantum state, leaving no room for movement in the classical sense. Neutrons cannot change positions, cannot shift, cannot rearrange. They are locked in place by the Pauli exclusion principle, yet their momenta remain high. They vibrate with enormous energy, not because they want to, but because confinement forces momentum to increase. Motion fails, but pressure rises. A neutron star is a tomb of motion that cannot express itself, a prison where movement becomes tension rather than flow. Even more extreme is the hypothetical quark-gluon plasma core that may exist in the densest neutron stars. Here, quarks no longer remain confined inside protons and neutrons. They form a soup where identity blurs. Yet within this soup, motion becomes meaningless again. Quarks interact so intensely that individual movement cannot be distinguished from collective behavior. Motion dissolves into coherence, into a kind of quantum rigidity so absolute that nothing can move independently. The third place where motion collapses is the event horizon of a black hole, a boundary beyond which motion becomes fate. At the event horizon, space falls inward faster than light can escape. Motion cannot fight this flow because it is not motion through space, it is motion of space. Every particle, every wave, every form of energy becomes trapped in a geometry that eliminates the possibility of outward movement. Even light, which in every other region of the universe remains the fastest form of motion, becomes still relative to the horizon, not because it stops moving, but because the space it tries to cross is flowing inward faster than it can travel outward. Inside the event horizon, the very idea of motion becomes distorted. Time stretches, paths bend inward. No direction leads away from the singularity. All trajectories converge. motion does not vanish. It becomes singular, funneled into one inevitable path. Beyond the event horizon, all forms of motion become identical, falling. The universe shows here that motion can be stripped of choice, direction, meaning. A particle falling toward a singularity does not move freely. It moves because no alternative exists. Motion fails by becoming predetermined. But motion's collapse is not only found in cosmic extremes, it also occurs in places where opposing motions cancel each other. The calm surfaces of lakes, the eye of a hurricane, the equilibrium points where gravitational forces balance perfectly. These are mundane but profound examples. In these quiet zones, motion persists beneath the surface, yet the visible world appears still. This facade of stillness is an illusion created by symmetry. Two opposing motions balance perfectly. But just as the primordial universe once held perfect balance, this balance is temporary. A gust of wind, a passing star, the tiniest fluctuation breaks the equilibrium, and motion returns. There is also a place where motion fails in a conceptual sense: singularities. Not just the singularities inside black holes, but the mathematical singularities at the edges of our physical theories. Singularities are not locations. They are failures of description. They represent points where the equations that govern motion cannot predict what happens next. In these conceptual boundaries, motion becomes undefined. It is not that motion stops. It is that motion cannot be described. Our understanding collapses, leaving a void where knowledge ends but physics continues. Motion fails not in the universe, but in our ability to understand it. And finally, there is the place where motion fails in the most profound way: the far future of the cosmos. As expansion accelerates, galaxies drift apart, stars burn out, black holes evaporate, matter decays, the universe grows colder, motion slows. But even as motion diminishes, it never disappears. The vacuum still trembles with zero-point energy. Virtual particles still appear and vanish. Quantum fields still fluctuate. Motion fades into something thin and ghost-like, but it does not die. Motion fails only when the universe becomes so empty that events cease to have meaning. But even then, tiny fluctuations ripple through the vacuum, refusing to let symmetry return. Absolute stillness was only possible before motion began. Once broken, the symmetry that allowed stillness can never be restored. Motion fails in places, but never fully. In the silence inside particles, motion fails. In the cores of neutron stars, motion fails. At the event horizon of black holes, motion fails. In perfect equilibrium zones, motion fails. In the heat death of the universe, motion fails. But in each case, failure is incomplete. Motion never disappears. It only changes shape. It hides. It softens. It becomes a shadow of itself. A reminder that the universe once knew stillness, and that stillness was broken forever. You, too, are built from motion that hides silence inside itself. Every cell in your body contains quiet configurations held beneath restless activity. You are made from places where motion fails just enough to let form exist, but not enough to let time stop. Motion cannot fully fail, and stillness cannot fully return. The universe lives in the tension between the two. Even as the universe stretches itself across billions of years, as motion fills every corner of existence with an unending choreography of particles, waves, stars, and galaxies, there remains a presence beneath all of it, a persistent echo, a faint memory of what the cosmos once was before motion began. Not a memory in the human sense, with images or language, but a memory built into the laws of physics themselves. A memory embedded in the constants that never change, in the symmetry that never fully dies, in the trembling baseline of quantum fields. A memory of the universe during the time when nothing moved, not because it chose stillness, but because it had not yet learned how to move. This memory is subtle. It does not announce itself through events. It whispers through limitations, through boundaries, through the things the universe allows and the things it forbids. Every law of physics carries a hint of the old stillness, a remnant of the state that existed before motion emerged. And to see that memory clearly, one must look not at the motion itself, but at the constraints that shape it. Consider the speed of light. Why should there be a maximum speed at all? Why should the universe impose a restriction on how fast information can travel? The answer lies in the original symmetry of space-time. In a perfectly still universe, where no point differs from any other point, signals cannot outrun the structure that connects the entire cosmos. The speed of light is the echo of a once uniform space-time, a limit that preserves something of the original stillness. No matter how fast motion becomes, it cannot exceed the quiet backdrop on which all movement occurs. Or consider inertia, the resistance of matter to changes in its motion. Inertia is the universe's way of remembering that stillness was once the default state. It is the imprint of symmetry left on matter. When you push an object and it resists, that resistance is the memory of a time when movement was impossible. Inertia does not express the impossible return to stillness. It expresses the difficulty of escaping its shadow. Mass itself is another form of memory. Before the Higgs field settled into its final configuration, motion had no distinction. Everything would have moved at the speed of light. But the universe chose a broken symmetry, a state with lower energy but greater diversity. Particles gained mass, and with mass came resistance to acceleration. The Higgs mechanism is the universe's confession that it once lived without mass, without inertia, without the complications that make motion slow and structured. Mass is the record of that transition. Even entropy, the tendency for disorder to increase, holds the memory of stillness. Entropy measures the distance between the current state of the universe and the perfectly symmetric, perfectly uniform state that existed before motion began. Each rise in entropy is a step farther from that primordial stillness. Entropy grows because the universe remembers that it once could not change, and every change it undergoes widens the gap between what it is and what it once was. But the memory is not only written in the laws, it is written in the structures of the universe as well. The cosmic microwave background, the faint glow that fills all of space, is a fossil of the early universe, the last trace of a time when matter and light moved as one fluid. It carries within its gentle fluctuations the imprint of the moment's stillness fractured. In its subtle temperature differences, we can see the first ripples that grew from the tiniest deviation in the vacuum. These ripples are the fingerprints of motion, learning how to express itself. The moment when the universe first gained the ability to differentiate one place from another. In the formation of galaxies, we see the memory of those fluctuations made large. The structure of the universe, the cosmic web of filaments and voids, comes from quantum variations amplified by inflation. If the early universe had remained perfectly still, perfectly symmetric, no structure would exist. The galaxies themselves are memories of stillness breaking. Every spiral, every cluster, every luminous curve is an echo of that first tremor. Even the expansion of the universe is a reminder of its first instability. Expansion did not begin as motion. It began as the consequence of symmetry collapsing. The vacuum energy released from that collapse drove inflation, stretching space at unimaginable rates. And though inflation ended long ago, the vacuum has never fully returned to equilibrium. Dark energy remains, an echo of that original imbalance, pushing the universe outward in a slow, persistent drift. Expansion is the universe still remembering that it once broke apart from perfect stillness. In black holes, the memory becomes more dramatic. Near the event horizon, space-time curves so severely that motion becomes constrained to a single fate, falling inward. The singularity itself if it exists as we imagine, is the closest the universe ever comes to recreating the conditions before motion. A state where no difference exists between directions, where destiny is uniform, where all trajectories converge. It is a mathematical shadow of the primordial stillness, but one reached not by symmetry, but by collapse. And yet, these memories are not tragedies. They are part of the universe's story. Even consciousness, the most delicate phenomenon of all, carries this memory. Your thoughts are patterns of motion, electrical pulses, chemical flows, shifting gradients. But beneath these patterns lies something persistent, your sense of continuity, the feeling that you remain yourself across moments. That continuity comes from the stability of the particles that make up your brain, the unchanging constants of physics, the enduring shape of the laws that define you. Consciousness is motion built on a foundation that remembers stillness. Every time you sit in quiet, every time your breath slows, every time your mind settles, you touch something ancient. Not the stillness of absence, but the trace of a universe that once had no sound, no change, no direction. Your calm is a tiny reflection of the cosmic calm that existed before motion began. It is the echo of the silence that shaped you. But the memory inside the universe is not static. It evolves as motion deepens. The farther time carries the cosmos from its origin. The more faint the memory becomes, but it never vanishes. It expresses itself in boundaries, in limits, in the rules that shape motion. The universe refuses to forget entirely. It carries its origin the way a scar carries a story, the way a deeper truth hides beneath the surface of action. What would the universe be without this memory? It would be unstable. Laws would shift. Motion would lose coherence. Structures would dissolve. The consistency of reality depends on the memory of the time before motion, the memory encoded in constants, in symmetry fragments, in quantum foundations. Without that memory, motion would have nothing to move against, nothing to push, nothing to shape. Motion requires a background, and that background is the stillness the universe once knew. And so, even though motion now fills everything, every star, every atom, every breath, the memory of that earlier universe persists within you, in the way your heart finds rhythm, in the way your thoughts find order, in the way your cells maintain their shape. You are composed of particles whose identity has not changed since moments after the beginning. You are made of silence, wrapped in motion. When you close your eyes, you can sense it not as an idea, but as a feeling, a quiet beneath the noise of thinking, beneath the pulse of your blood, beneath the vibrations of life. It is not stillness. It is the memory of stillness. The universe remembers what it was, even as it continues moving forward. And perhaps that is why motion feels natural and rest feels restorative. Motion is what the universe does. Rest is what it remembers. Motion is the story. Stillness is the origin. And you carry both. As the universe carried its faint memory of stillness deeper into the ages of motion, another truth began to crystallize within the structure of reality, one that hides beneath the elegant flows of galaxies and the quiet trembling of particles. It is a truth that seems counterintuitive at first, because everything in our experience tells us that chaos is the threat, that disorder is the danger, that unpredictability brings destruction. But at the level of cosmic architecture, at the level of fundamental existence, the opposite is quietly, relentlessly true. Stillness, not chaos, is the most dangerous state the universe can ever approach. To understand this, we must return not to the primordial stillness itself, but to the conditions that allowed it to collapse. Perfect symmetry is not peaceful. It is unstable. A universe without motion is a universe balanced so precariously that the slightest deviation, one fluctuation in a field, one shift in energy, can unravel everything. The pre-motion universe sat upon the narrowest ridge imaginable, an infinite plateau where no possibility stood apart from any other. But perfect uniformity is not harmony. It is tension without direction. A single crack brings the entire symmetry down, forcing the universe into a new state, a new geometry, a new existence. In this way, stillness is not safe. It is fragile. The moment symmetry collapses, the stillness dies instantly, violently, forever. Motion floods in because motion is what symmetry had been holding back. The reason motion cannot be removed is the same reason stillness cannot survive. The more perfect the symmetry, the more catastrophic its collapse. Perfect balance is the most unstable state of all. Chaos, in contrast, is forgiving. It responds gradually. Chaos spreads in degrees. It distributes energy instead of concentrating it. In a chaotic system, a small disturbance may create turbulence, but it rarely destroys the entire system. Chaos can be navigated, diffused, transformed, but stillness shatters. Stillness has only two possible states: unbroken or gone, nothing in between. This truth is written into every law of physics. Temperature, for example, is motion. When motion stops, temperature falls. At absolute zero, matter is forced into a perfect, motionless arrangement. But this arrangement is so unstable that any attempt to reach absolute zero triggers quantum fluctuations that restore motion. Perfect stillness cannot be achieved, not because the universe resists cold, but because stillness threatens the foundation of reality. The closer one gets to perfect stillness, the more quantum mechanics, the deepest architecture of existence, fights back. The uncertainty principle exists partly for this reason. If a particle were perfectly still, its momentum would be exactly zero, and its position perfectly known. But such precision is forbidden. The equation collapses. The stillness becomes mathematically illegal. And so the universe injects motion in the form of uncertainty, a subtle trembling that keeps the foundations from falling into perfect symmetry again. Even the vacuum itself behaves this way. When energy empties from a region of space, the quantum fields do not fall silent. They vibrate with zero-point energy, a kind of faint emergency motion that prevents vacuum instability. Were the vacuum truly still, perfectly flat, perfectly uniform, it could again collapse into a catastrophic symmetry-breaking event, tearing the universe into a new configuration. The trembling of the vacuum is not a flaw, it is a safeguard. And gravity, the master sculptor of structure, hates stillness more than any other force. A cloud of gas left undisturbed does not remain still. Gravity forces it into collapse. A galaxy left static collapses into a denser form. A star left perfectly balanced implodes once fusion fails to push outward. In the universe, standing still means falling inward. Gravity punishes stillness immediately and rewards motion with stability. Planets survive because they orbit. If they tried to stop, they would plummet into their stars. Moons remain afloat because their motion counteracts gravity's pull. Everything that stops moving in a gravitational well is devoured by it. But the danger of stillness grows clearer in the interiors of stars. Fusion is a form of motion nuclei, overcoming repulsion to join together. When fusion stops, motion fails, and the star collapses. The core, crushed by gravity, becomes a neutron star, or a black hole. The absence of motion causes implosion, triggering some of the most violent events in the universe. Supernovae, the energetic deaths of stars, are born from the cessation of internal motion. When the fuel runs out and motion ceases, the star dies catastrophically. Stillness is dangerous because it is irreversible. Once motion inside a star fades, gravity does not slow down. It rushes inward. The star cannot recover. True stillness inside matter is fatal. On the scale of galaxies, stillness is equally perilous. If the dark matter halo surrounding a galaxy stopped its swirling, the galaxy's structure would unravel. Stars would fall toward the center. Spiral arms would collapse. The galaxy would lose its identity. Galactic balance requires motion. Without motion, gravity would consume everything. Even in planetary systems, stillness is an existential threat. Planets must orbit, they must rotate, they must shift energy through weather cycles. A world without motion cannot redistribute heat. One side burns, the other freezes. Weather collapses, oceans stagnate, climate dies. Habitability requires motion. Life requires motion. But the most significant danger of stillness lies in the fate of time. Time itself is defined by motion. When motion stops, time stops. Without motion, there are no events, no change, no sequence. A region without motion is a region without time, a region where the progression of existence halts. Time flows because motion creates difference between moments. Remove motion, and the concept of before and after dissolves. The universe knows this. It experienced the cost of stillness once. In the era before motion began, that perfect symmetry was a fragile prison. When it broke completely, reshaping everything. This is why the universe never returns to stillness. Why entropy increases. Why zero-point motion persists. Why dark energy accelerates expansion. Why particles tremble. Why atoms never fully rest. Everything in the cosmos conspires to ensure the universe never risks the catastrophic fragility of perfect stillness again. Even life reflects this principle. Living organisms fall apart when motion stops. Cells die when they cease to circulate nutrients. Neurons stop communicating. Hearts stop beating. Bodies collapse into entropy. Life itself is an argument against stillness. It exists only when energy flows. Life is a celebration of motion, a declaration that stillness is the enemy of continuity. But the danger of stillness becomes most profound when we look toward the far future of the universe. As expansion accelerates, galaxies drift apart until they become isolated islands. Stars die, leaving behind white dwarfs, neutron stars, and black holes. Even these remnants eventually fade. Over unimaginable timescales, motion slows as the universe approaches heat death. And one might assume that this final state is a return to stillness. But it isn't. It is a warning. In heat death, motion becomes thin, almost ghost-like, but it persists. Quantum fluctuations refuse to vanish. Zero-point energy refuses to flatten. The vacuum refuses to calm. The universe cannot allow stillness to return. If absolute stillness were to emerge again, symmetry would rise, and the universe would face the same catastrophic instability that preceded its creation. Motion keeps the universe safe by preventing the conditions that would collapse it into uniformity. Stillness is more dangerous than chaos because stillness is the threshold of unmaking. Chaos can be navigated. Chaos lets systems reorganize, adapt, transform. Stillness suffocates. Stillness threatens to erase all difference. Stillness invites collapse. The universe chooses motion because motion protects it from itself. You feel this truth in your own body. Rest rejuvenates you, but too much stillness becomes decay. Muscles weaken, blood stagnates, thoughts grow dull, life fades. Your biology knows what the universe knows. Motion is survival. Stillness is the beginning of collapse. Even your breath, the simplest motion you perform, is a defense against the stillness that would end your existence. Motion is not merely the story of the universe. It is its shield, its safeguard, its refusal to return to the fragile perfection that almost broke everything. And as long as motion continues, even in the faintest trembling of the vacuum, the universe remains awake. As motion spread through the universe like a pulse that could not be silenced, its purpose slowly became clearer, not to create beauty, not to generate complexity, not to carve galaxies or ignite stars, but to keep the universe alive. Motion was more than a consequence of broken symmetry. It was more than an escape from stillness. Over billions of years, as energy flowed, as matter arranged itself, as gravity sculpted and entropy advanced, motion revealed its deeper role. It became the universe's method of survival, a mechanism, not merely an accident, an instinct, not merely a condition. In the earliest moments after symmetry fractured, the vacuum found itself flooded with potential outcomes. The universe could have collapsed instantly. It could have expanded too fast for structures to form. It could have remained a soup of radiation with no matter. It could have dissolved into chaos that never cooled, never settled, never allowed atoms to assemble. But motion, guided by laws shaped from the broken symmetry, prevented these failures. Expansion cooled the universe. Cooling allowed particles. Particles allowed atoms. Atoms allowed chemistry. Chemistry allowed stars. Stars allowed life. At every step, motion rescued the cosmos from stagnation. Consider the expansion of the universe. Had expansion slowed too soon, gravity would have crushed everything back into a singular point. Motion prevented collapse. Had expansion accelerated too quickly at the beginning, matter could never have clumped into galaxies. Motion slowed at precisely the right moment. The way space expanded was not random. It was the universe adjusting to the instability created by symmetry breaking. Expansion may look like outward movement, but it is the universe's first survival reflex, an instinctive response to avoid collapsing into perfect uniformity again. Even gravity, which seems at first like the opposite of expansion, is part of this survival mechanism. Gravity gathers matter. It allows structure. It makes complexity possible. Without it, the universe would be a thin mist of particles, drifting endlessly apart, too diffuse for stars, too empty for chemistry, too cold for life. Gravity, by pulling matter inward, ensures that energy remains concentrated enough to ignite the engines of creation. Gravity's motion toward collapse is balanced perfectly by expansion's motion toward separation. The universe lives between these two motions, surviving because neither dominates completely. Inside stars, motion becomes even more literal. Nuclear fusion is a process that holds off gravitational collapse for billions of years. It is the motion of nuclei overcoming their repulsion to produce heavier elements. This motion sustains stars. It stabilizes them. It prevents their cores from collapsing prematurely. And when fusion ends, when motion fails, stars die violently. Their end is the universe's reminder that stopping motion is catastrophic, not only for the star but for the cosmos itself. Supernovae seed space with heavy elements, the ones needed for planets, atmospheres, life. The violent death of a star is motion reasserting itself in one final, powerful act of survival. Even the coldest regions of space demonstrate this principle. In the near absolute zero temperatures of molecular clouds, motion is faint but never gone. If motion ceased entirely, gravity would collapse the cloud too quickly, preventing star formation. But the faint jitter of particles provides just enough pressure to control the collapse. Motion regulates gravity's hunger, ensuring that clouds do not implode all at once, but form stable cores that ignite as stars over millions of years. This delicate balance between faint motion and overwhelming gravity is part of the universe's survival logic. Distribute creation over time, not all at once. Maintain continuity instead of catastrophic events. The way galaxies rotate also reveals motion's role as a survival mechanism. Without rotation, galaxies would collapse into dense spheres, chaotic and short-lived. Rotation spreads matter into stable disks, extending the lifespans of stars, regulating star formation, and preserving the integrity of the galactic structure across billions of years. The spiral shape, a calm swirl anchored by dark matter, is motion becoming architecture. Rotation prevents collapse, preserves order, and distributes gravity's influence across vast distances. A galaxy that rotates survives. A galaxy that stops moving dies. On planets, motion becomes metabolism. Wind patterns distribute heat. Ocean currents regulate climate. Planetary rotation prevents temperature extremes. Tectonic motion recycles minerals. Magnetic fields generated by the motion of molten cores, shield worlds from cosmic radiation. Every form of habitability arises from motion. A motionless planet is sterile, stagnant, dead. The Earth survives because it moves, because heat flows from core to surface, because atmosphere circulates, because ocean currents breathe life into climate. Life emerges because motion circulates the conditions that allow organisms to thrive. In organisms themselves, the survival mechanism becomes even clearer. Life is motion arranged into cycles. Cells pump ions. Proteins fold through dynamic interactions. DNA replicates through shifting chemical bonds. Muscles contract. Neurons fire. Blood flows. Without motion, even at microscopic scales, life ceases instantly. Every heartbeat is a reminder that stillness is death. Every breath is a negotiation with entropy. Life resists decay by using motion to delay equilibrium. Survival is the art of dancing away from stillness for as long as possible. Even evolution depends on motion, not physical motion, but the motion of information. Genes shift, populations migrate, ecosystems transform. The survival of species is a matter of moving through environments, through climates, through challenges. Stillness leads to extinction. Motion leads to adaptation. The universe ensures survival by guaranteeing that nothing remains fixed. But the survival mechanism is deepest not in matter, life, or galaxies. It is deepest in time itself. Time flows forward because the universe moves. If time ever stopped, if motion halted completely, the universe would revert to its primordial symmetry, and existence would end. Time is the universe's most profound survival strategy, a guarantee that change always continues, that motion always unfolds, that nothing remains trapped in the dangerous perfection of stillness. Entropy, often misinterpreted as decay, is also part of this mechanism. Entropy forces systems away from equilibrium. It ensures that energy spreads. It ensures that nothing returns to the uniform, high symmetry state that existed before motion. Entropy is not the universe falling apart. It is the universe preventing itself from returning to the fragility of absolute symmetry. Entropy is survival. Dark energy, too, can be seen through this lens. It accelerates expansion, preventing gravity from pulling everything back into a singular collapse. Too much collapse would bring the universe into another perfect point, a dangerous stillness, a dead symmetry. Expansion wins to prevent this. The universe spreads itself thin, not to fade, but to remain safe. Dark energy does not oppose life. It protects the cosmos from its own potential instability. Even black holes, which seem like places where motion ends, reveal motion's necessity. Inside the event horizon, all motion is forced inward, but it does not vanish. Instead, it becomes curvature. Singularities, if they exist, are not still points, but the breakdown of motion's description. Hawking radiation, the evaporation of black holes, is motion returning to the universe. Black holes die because motion refuses to leave space-time imprisoned. Gravity tries to trap motion. Quantum mechanics ensures escape. Survival is written into the physics that governs even the darkest objects in existence. In the far future, when stars fade and galaxies drift into cosmic silence, motion will still be the mechanism that preserves what remains. Zero-point energy will resist perfect stillness. Virtual particles will flicker. Quantum fields will hum softly. Even in heat death, the faint trembling of the vacuum keeps the universe from collapsing into uniform symmetry. Motion becomes minimal, but it remains, because without it, reality would have to reset, and resetting would destroy everything that ever existed. The universe survives by never allowing stillness to return. You survive for the same reason. When you breathe, you resist equilibrium. When your heart beats, you push against entropy. When you think, you generate ordered motion in a sea of chaos. You are alive because motion protects you, and the universe is alive for now because motion protects it too. Motion is not random. Motion is not a byproduct. Motion is not optional. Motion is the universe saving itself. Long after motion had become the defining story of the universe, after it saved the cosmos from collapse, after it carved galaxies and lit stars and stirred the chemistry of life, there remained certain realms where motion was never meant to go. Places that seemed forbidden regions, so extreme, so delicate, or so abstract that motion should not have been able to exist within them. And yet, motion reached them anyway. It found pathways, loopholes, cracks in the structure of reality, infiltrating domains that appeared sealed off by the very laws that govern the cosmos. In these forbidden places, motion behaves differently, bending itself around rules that were never designed to accommodate it, rewriting what those places mean simply by existing within them. The first of these forbidden regions lies in the vacuum itself. Before motion began, the vacuum was the stage on which symmetry rested, perfectly uniform, perfectly still, perfectly balanced. In that primordial era, no point in space could be distinguished from another. No fluctuation could survive. No direction could be preferred. No change could propagate. Motion did not merely avoid the vacuum, it was excluded by it. And yet, as soon as symmetry broke, the vacuum transformed into something entirely different. A seething undercurrent of zero-point motion, virtual particles appearing and vanishing, waves of energy trembling in place. The vacuum became one of the most dynamic regions in existence. Motion was never supposed to reach the vacuum, because the vacuum was supposed to be nothing. But instead, the vacuum became the busiest nothing imaginable. The second forbidden zone is the interior of atoms. Classical intuition tells us electrons should orbit a nucleus, like moons orbiting planets. But quantum reality forbids such orbits. An electron cannot move in a classical circle without radiating away energy until it collapses into the nucleus. By all logic, atomic motion should fail. Electrons should spiral inward. Atoms should not exist. Yet quantum mechanics invents a solution that breaks the classical rules entirely. Electrons become standing waves, occupying regions of space where motion is both everywhere and nowhere at once. They are not objects following paths, they are patterns held in place by probabilities. Motion reaches into this forbidden region by transforming itself, not as trajectory, but as presence. Not as movement, but as vibration. Electrons never stop moving, yet they never follow a path. Motion in the atomic world becomes something that was never supposed to exist. Motion without a journey. The third forbidden realm is the core of stars. Temperature and pressure rise to such unimaginable heights that protons positively charged and naturally repulsive should never collide. Fusion should be impossible. The Coulomb barrier should be absolute, but motion forces its way in through quantum tunneling. Two nuclei approach, restrained by the rules that should separate them forever. And yet, a flicker of probability allows them to appear on the other side of the barrier, fusing into a single nucleus. Motion reaches a region where classical physics has no authority. It pushes through by leaning on the uncertainty baked into reality. Without this illicit motion, stars would never shine. The universe would remain a cold expanse of dark matter and dim hydrogen. Life would never form. Motion in stars is a trespasser and a savior. Then there is the forbidden frontier of black holes. At the event horizon, space falls inward, faster than light can escape. No information can cross outward. No object can avoid the inward flow. Motion appears to end here. It appears to lose its meaning. The event horizon forbids escape by definition. And yet motion finds a way in the form of Hawking radiation. Quantum fluctuations near the horizon can create pairs of virtual particles, one falling inward, the other escaping. The escaping particle becomes real, carrying away energy. Black holes evaporate because motion refuses to be fully trapped. Even the most extreme gravitational well cannot silence the trembling of the quantum vacuum. Beyond the event horizon, motion warps even further. Classical trajectories collapse. Space-time curves so sharply that no direction is stable. But the motion of curvature itself, the motion of geometry, persists. The singularity seems like a place where motion should vanish entirely. A point of infinite density. A place without extension, without space, without time. But singularities are not real locations. They are breakdowns in our equations. Regions where our descriptions fail. Motion does not stop there. It becomes indescribable. What appears to be forbidden is not motion itself, but our ability to understand it. Another forbidden place is the early universe during inflation. When inflation occurred, space expanded faster than motion could propagate, faster than light, faster than causality. In this era, motion should have been irrelevant because no particle, no wave, no influence could outrun the expansion. And yet, quantum fluctuations survived inflation. They were stretched across the universe but were not erased. Motion imprinted itself on the cosmic microwave background, leaving tiny temperature variations that would one day grow into galaxies. Motion reached a region where expansion tried to erase it, yet motion became the very seed of structure. The forbidden region became the birthplace of everything. Even absolute zero, long considered the ultimate forbidden state for motion, turns out to be porous. Motion is not supposed to exist at that temperature. In classical physics, absolute zero means the complete absence of kinetic energy. But quantum mechanics refuses to allow the universe to sit in perfect stillness. Zero-point motion remains, a faint trembling, a minimum vibration that cannot be removed. Absolute zero, the ultimate stillness, becomes merely a boundary motion, approaches but never crosses. The forbidden state becomes unreachable, not because the universe lacks cold, but because the universe forbids perfect stillness. Another place motion should not reach is the expanding boundary of the cosmic horizon. As dark energy accelerates expansion, distant galaxies recede faster than their light can travel to us. They cross the horizon, becoming unreachable forever. In theory, motion within those galaxies should no longer influence us in any way, and yet gravitational waves can still stretch space-time at local scales, even if their sources lie beyond the horizon. The shape of space-time remembers motion from regions we will never see. Even when distance forbids motion from reaching us, curvature carries its signature. Motion also reaches into the forbidden domain of entropy's end, the far future where the universe approaches heat death. In this state, motion should have faded to nothing. Processes should halt. Energy should equalize. But entropy never reaches its maximum. The universe never completes its approach to stillness. Quantum fluctuations ensure that motion persists. Even in the coldest, emptiest future, virtual particles appear and vanish. Zero-point fields tremble. The vacuum hums. A universe with no stars still has motion. Stillness, the forbidden endpoint, remains forever out of reach. But perhaps the most intimate forbidden region is within ourselves, inside consciousness. Thought should not exist. If the universe were ruled by strict determinism, if particles moved solely by classical laws, awareness would be impossible. Consciousness is not a classical phenomenon. It arises from networks of neurons, whose behavior depends on quantum processes, chemical flows, electrical gradients. The brain is a place where motion should be too chaotic, too noisy, too random to produce ordered inner experience. And yet, motion inside neural tissue organizes into stable patterns. Thought emerges. Reflection emerges. Choice emerges. Consciousness is motion, intruding into a domain that appears too complex, too delicate, too improbable. The forbidden region becomes the source of meaning. And all of these forbidden reaches, cosmic, atomic, biological, point to one truth. Motion is not simply allowed. It is persistent. It is opportunistic. It leaks into every space the laws of physics do not explicitly forbid, and some they do. Motion is not just a property of matter. It is the universe's refusal to accept boundaries. It is the ancient instinct, born the moment symmetry broke. Motion was never meant to reach the vacuum, but it did. It was never meant to reach the atom's interior, but it did. It was never meant to reach beyond the event horizon, but it did. It was never meant to survive inflation, but it did. It was never meant to persist after heat death, but it will. And motion was never meant to spark consciousness. But here you are, breathing, sensing, thinking, moving. You are built from forbidden motion. You are proof that motion never stays where it is told. As the universe continues unfolding across its vast horizon of time, moving from its trembling beginnings to the complex structures of galaxies, to the brief flicker of life on scattered worlds, and finally into a future defined by fading light and stretching space, a question lingers beneath every form of motion. What is the universe trying to become? Motion is not random. It is not meaningless. It is not noise. Motion is direction. Motion is intention without consciousness, purpose without planning. Every gesture of the cosmos, from the swirl of gas clouds to the drift of superclusters, hints that the universe is evolving towards something not because it has a goal, but because its laws push it steadily into new states that reflect the boundaries and potentials of its earliest fracture. To understand what the universe is trying to become, we must look not at the motions themselves, but at what they create. The first motion created space that could expand. That expansion allowed cooling. Cooling allowed matter. Matter allowed structure. Structure allowed gravity to sculpt. Gravity allowed stars to burn. Stars allowed elements to form. Elements allowed chemistry. Chemistry allowed life. Life allowed consciousness. Each stage builds on the motion that came before it. Each stage refines the universe into something richer. And while none of these developments were inevitable, the architecture of motion makes them likely. The universe evolves not because of chance, but because motion drives it into complexity. Consider the earliest phase, when expansion slowed just enough to allow matter to clump. If motion had been slightly different, faster or slower, the universe would have shaped itself into a barren emptiness or collapsed into fire. Instead, motion found a narrow corridor through possibility space, carving a path where stars could form, where planetary systems could crystallize, where life could eventually awaken. The universe behaved as if it were searching for stability, settling into states that could endure for billions of years. Motion is the vehicle of that search. Stars, too, act like organisms in cosmic time. They gather matter, fuse fuel, radiate energy, and eventually die. Their lives are cycles of transformation, each one carrying the universe a little further from its simple beginnings. Fusion creates heavier elements. Supernovae distribute them. Planetary systems condense from their ashes. Every star is an engine that pushes the universe toward greater diversity of matter. Through motion, the universe transforms its own composition. What began as pure hydrogen and helium becomes carbon, oxygen, iron, silicon materials capable of forming worlds, oceans, atmospheres, and bodies. On those bodies, motion becomes metabolism. Chemical networks adapt. They replicate. They evolve. Life begins not as a plan, but as the natural extension of molecular motion in the presence of energy gradients. Once life arises, new forms of motion take shape, behaviors, instincts, migrations. The universe begins to move through the minds of the creatures it forms. Motion becomes intention. Motion becomes reflection. And, eventually, motion becomes self-awareness. Through consciousness, the universe begins observing itself. It learns through the eyes of living organisms what stars look like from afar. Through telescopes, it builds, with hands made of stardust. It studies the very motions that created it. Conscious beings become the first structures in the cosmos capable of questioning motion itself. They map galaxies. They track the drift of planets. They measure the expansion of space. And in doing so, the universe begins to comprehend its own unfolding. What is this, if not evolution, not biological, but cosmic? Motion driving matter into structure. Structure driving complexity. Complexity driving awareness. Awareness driving understanding. The universe is trying to become something that can understand itself. This does not imply intention. The universe has no mind, but the rules that govern motion produce outcomes that resemble growth. Systems become more intricate, patterns become more layered. Order emerges from chaos through the self-organizing flows of energy and matter. Stars form because it is the easiest way for the universe to distribute gravitational energy. Life forms because it is the easiest way to dissipate chemical gradients. Intelligence forms because it is the easiest way for organisms to optimize survival. In every case, motion finds the path of least resistance, and that path leads, again and again, toward increasing complexity. Yet the universe is not trying to become complex for complexity's sake. It moves toward states that maximize entropy while allowing temporary pockets of low entropy oases where order can flourish briefly. In these pockets, motion becomes delicate. Planetary climates stabilize. Ecosystems mature. Civilizations rise. Thought appears. And in those moments, the universe becomes something it has never been before. A subject that can reflect upon its own origin. Still, the universe is not done becoming. Its future extends far beyond the era of stars and life. As dark energy accelerates expansion, galaxies will drift apart. Stars will exhaust their fusion fuel. Black holes will evaporate. The universe will cool toward a thin whisper of radiation. And yet motion persists, because even in this dark era, transformation continues. Black hole evaporation is motion in the form of quantum tunneling. Proton decay, if it occurs, is motion in the form of particle transformation. Even as matter thins, the vacuum hums with motion so faint it borders on nothingness, yet never fully becomes nothing. Through this long decay, the universe appears to be moving towards simplicity. But the simplicity is not stillness. It is a highly diffuse, highly uniform state, an echo of the early uniformity, but not identical to it. The universe becomes a vast, cold field of faint motion, and this final state, heat death, is not an end, but a transformation into a new form. Motion becomes the faint trembling of quantum fields, not gone, but minimal. The universe becomes a single, extended, nearly featureless entity, vibrating quietly, with zero-point energy. In that distant future, one might imagine the universe trying to return to its beginning, to the stillness before motion. But that return is impossible. Symmetry cannot be restored fully. The universe cannot become what it once was. Time only flows forward. Entropy only rises. Memory only deepens. Yet in this distant, cold state, the universe achieves something it never had in the beginning: stability. A stability built not from symmetry, but from exhaustion. Motion continues only in its faintest form. The cosmos becomes a quiet field of restless calm. Is that what the universe is trying to become? A stable, cold, diffuse field of trembling potential? Or is the universe trying to become something else, something that emerges not at the end, but within the middle of its life? The emergence of consciousness suggests another possibility. Motion drives the universe not only toward decay, but toward awareness. And awareness allows meaning to appear, even if briefly. For a fleeting moment, cosmically speaking, the universe becomes capable of wondering why it moves, why it exists, why it wakes from stillness. Perhaps the universe is trying to become a witness to itself, not in a mystical sense, but in a structural one. Motion creates complexity. Complexity creates consciousness. Consciousness creates reflection. Reflection creates understanding. Through living beings, the universe gains the ability to look back across its own history and see the arc of its transformation. That arc begins with stillness, erupts into motion, drifts into complexity, collapses into decay, but never forgets its origin. You, in your quiet moments, participate in this arc. When you contemplate the cosmos, you are the universe contemplating itself. When you breathe, you carry forward the motion that began at the first vibration of the vacuum. When you think, you give form to the complexity that motion sculpted over billions of years. The universe may not have intention, but motion pushes it towards states that allow intention to arise inside temporary structures like you. So, what is the universe trying to become? Something that remembers, something that understands, something that endures in motion even as motion fades. In every star, in every atom, in every breath you can feel it trying. The universe is trying to become aware of itself. And through you, for a moment, it succeeds. As the universe stretches deeper into the far future, drifting past the age of stars, past the age of galaxies, past even the age where matter itself still holds together, motion begins to slow, not because it wants to, but because the structures that once carried motion begin to unravel. The stars that spun for billions of years release their last light. White dwarfs cool into black dwarfs. Neutron stars leak heat into the void. Black holes evaporate through Hawking radiation, losing their mass grain by grain. Gravity weakens as matter thins, as particles decay, as the cosmos expands into a cold, dark ocean of almost nothing. At this stage, one might be tempted to say that motion ends, that the universe, after so long resisting stillness, finally succumbs to the silence that predated all things. But the truth is softer, stranger, deeper. Motion does not end. It changes shape. It becomes something subtle, something faint, something that survives in ways no structure or star could. As heat drains from the universe, the last remaining atoms drift apart. Their velocities slow. Collisions become rare. Entropy approaches its maximum not through destruction, but through dilution energy, spread so thin that differences vanish. A hydrogen atom might travel for trillions of years before encountering anything else. The darkness is not a blanket but a vast separation, an expanding loneliness. In this distant era, motion becomes nearly imperceptible, yet remains etched into the faint trembling of particles and fields. Even when all matter decays, if protons are not eternal, decay itself is motion. The transformation of a proton into lighter particles releases energy that moves outward through space, even if space has thinned to near emptiness. This is the paradox of the universe's ending. Motion becomes thinner than breath, quieter than light, softer than thought, yet it remains. Absolute stillness remains forbidden, not by choice, not by intention, but by the laws of physics that were set at the moment symmetry broke. Those laws refuse to allow certainty, refuse to allow perfect equilibrium, refuse to allow the vacuum to rest. And so, even when the universe enters its twilight, motion hums beneath everything. As black holes evaporate, the last grand engines of motion die. Their final photons drift away, stretching across expanding space until their wavelengths are longer than galaxies once were. Each photon is a memory of an event that happened in the deep past, an orbit, a collision, a collapse, encoded in light so faint it is nearly indistinguishable from the background. If an observer could exist in that era, they would see nothing with their eyes. But if their instruments were infinitely sensitive, they would detect the ghosts of motion long gone, dispersed across distances so large they defy language. Eventually, even these fading remnants of energy disperse. The universe becomes flat, dark, and cold. Yet even now, motion persists. Zero-point energy remains unavoidable, irreducible, woven into the quantum fabric. Virtual particles still flicker. Fields still fluctuate. The vacuum remains restless. This quiet trembling is not the motion of stars or galaxies, but it is motion nonetheless. In the final eons, motion becomes less about movement through space and more about the internal trembling of the fields that define reality. And here lies the truth. The universe cannot return to what it was before motion. The primordial stillness depended on perfect symmetry, and that symmetry was shattered. Once broken, it cannot be restored. The vacuum that exists in the far future is not the same vacuum that existed before the universe began. The first vacuum was balanced at an unstable peak. The final vacuum rests in a valley carved by billions of years of cosmic history. Even if motion fades into the faintest whisper, the landscape that gave birth to motion remains altered forever. The memory of motion shapes the quiet, so what remains after motion ends? Not stillness, not silence, not sleep. What remains is a thin, fragile persistence, a final echo of the universe's long journey. This echo cannot form stars, cannot ignite fusion, cannot create life, but it contains the story of everything that came before it. In the trembling of the vacuum, there is encoded the entire history of symmetry breaking. In the faint ripples of quantum fluctuations, there is encoded the shape of the laws that guided galaxies into spirals. In the ghostly background of stretched-out photons lies the imprint of the cosmic web. Nothing is left that can act, but everything is left that can remember. If motion truly ended, the universe would collapse back into perfect symmetry, and perfect symmetry is indistinguishable from non-existence. If motion truly ceased, time would stop. Without time, the universe cannot grow, cannot change, cannot mean anything. Motion is not a feature of the universe. It is the condition that allows the universe to exist at all. And so, instead of ending in stillness, the universe ends in tension, a nearly silent hum that prevents collapse. But this description of the far future is only one perspective. There is another way to understand what remains after motion ends, through the lives that motion once allowed. Every consciousness that ever arose, every moment of awareness, every thought and memory, every insight into the cosmos, becomes part of the universe's internal archive, not stored physically. Physical storage decays, but expressed in the legacy of motion itself. Consciousness is made of patterns. Patterns are made of motion. And these patterns shape the universe's evolution through observation, through reflection, through the organization of matter. Even if the beings who carried these patterns vanish long before the universe cools, the fact that they existed changes the meaning of the cosmos. The universe once contained observers, once contained life, once contained minds capable of looking back across time and understanding their place within it. This alone changes what remains. Because meaning, in whatever quiet, structural way the universe can hold, it is a residue created by motion. In the deepest darkness of the future, the universe carries the memory of having been observed, the memory of having produced complexity, the memory of having awakened, even briefly, through the flickering of countless minds. These memories are not stored in matter. They are stored in the shape of the universe's laws, in the disturbances left behind by ancient motion, in the shadows of processes that no longer unfold. The universe becomes its own archive, and if one stretches imagination further still into realms beyond physics, one could say that what remains after motion ends is the story of motion itself, the arc from trembling to galaxies to thought to silence. Not written on paper, not recorded in particles, but inherent, present in the structure of space, in the shape of energy, in the trembling of the vacuum. At the very end, when the universe is nothing but a cold, diffuse whisper, that whisper carries everything. So what remains after motion ends? The memory of motion, the memory of becoming, the memory of complexity that once rose from nothing, the memory of stars, of planets, of breaths, of thoughts, the memory of a universe that learned how to awaken from stillness. And within that memory, there is one last, quiet truth. Motion never ends. It only becomes too soft for us to hear, and in that softness, The universe keeps breathing, not in stars or galaxies, but in the trembling of the fields that outlive everything. A final, endless exhale.